I think we might be live. We might be live again. Well, I pressed the live button. We're gonna find out, aren't we? Welcome, everyone to the, well, nobody. I don't know who's watching. Don't think anyone's watching. That's great. Maybe you're watching later. If you're watching later, thank you. We are at day 3 of the hackathon. And we are building Braid. And if you don't know what Braid is, and if you have no idea what I'm talking about, or no idea what is going on, I am going to show you. We are going to go to GitHub, and we've got, where is it? Where are you? Oh, dearie me. It's just not there, is it? Yeah. Let's bring it up. Braid. Actually, I want to remove myself in a minute, but I've got Braid in the background. In a nutshell, Braid is a tool for reviewing and viewing and quickly navigating very large HAR files. A HAR file is a HTTP archive file. It's a whole conversation of the requests and responses that happen between a client and a server. And we are going to be we are building a tool that's going to allow us to quickly analyze that. Now, Braid was originally had two features, or it will have 2 features eventually. The first feature is what we're working on right now, which is the ability to very quickly load in a very large HAR file and immediately start navigating it. Will immediately be within reason. And hang on a minute, my audio keeps jumping up and down, and I don't know why. I don't know why it keeps doing that. It's not me. I'm hoping it's not messing up the video, but there's this auto jumping thing that keeps moving around. I have to keep an eye on that. It's new, as I said. I'm using this stuff for new, right out of the gate, and I'm trying to learn my way through all of it, and get all of the muscle memory that I need to be able to operate it effectively and efficiently. I'm still stumbling around a little bit at the moment, so you're kind of watching my learning journey. If you are watching, thank you. Again, this is not really intended for anyone to watch necessarily, but it is a lot of fun doing it. I'm having a lot of fun going through all of this. So back to what I was saying about Braid and HAR files. We're already kind of spent the last 2 days building out an engine that's going to be able to pass in those HAR files quickly. And you take the traditional route of just pass in a JSON file, but you can't pass in a JSON file. You can't just read in that entire JSON file as is, mainly because it could be 50 gig. It could be. I'm not saying that HAR files are always going to be that large, but I'm telling you, in enterprise applications they can be. You're dealing with, I've got a HAR file. I recorded it from me and my website, and it's like, it's 13 meg. Nice. Congratulations. It's typically not how they go, though. They're much larger, and the URLs are not friendly, and they're full of query parameters, and it's just really, believe me, enterprise applications are much harder to debug than your average, clean, brand new, from scratch API that you put together, or that you might have been using from a startup or a SaaS company. Enterprise applications tend to have years and years of legacy, all kind of baked in, and you got to work around that. So one of the first use cases is if you're on call. So again, I'm not sure if you remember or if you've been following along, but I work for a company called Cisco, and originally was for Splunk, but Splunk was acquired by Cisco. So now I work for Cisco, but I'm still a Splunker. My Splunk is still where I wanted to work. I chose to work. Now I work at Cisco. Not that Cisco's a bad place, it's just I chose Splunk. And we have an on-call process. We have a piece of software called on-call, but I'm not going to do that. We have an on-call process where it means if a customer is using our software, and it comes in different flavors, on-prem and our cloud stack, and on-call is for our cloud stack. If we have a customer that's using our cloud product, and something goes wrong. Things go wrong, they're doing a migration, doing an upgrade, doing a crazy search, or in some of our other products, when you're doing doing like, we have things called playbooks, which is basically a workflow engine, and it runs the original AI, if you will. Well, not really AI. It's kind of autonomous software, really. It's an automation engine. Anyway, lots of things can go wrong all over the place, and a lot of the time, the only thing we're going to get given from a customer is a HAR file. Here's me at my browser using the product, and this is what I saw. And that's it. We might get a few screenshots. We're lucky if we might get some console output. We might get some logs. Very unlikely. So that's what we have to start with. That's where, as an engineer, like, okay, there's a problem. And you as an on-call engineer, you don't know, you don't know where it is to begin with. So the area that it might have a problem, it might not be your level of expertise. So, it might be a back-end problem, but you're a front-end person. Or it might be a front-end problem, but you're a back-end person. And, okay, I got to diagnose this. I've got to get into this system. I've got to get under the skin of it, and I've got to understand it. Then I've got to debug it, and I've got to follow the path the customer took and figure out how I pull this together. It can be a bit daunting, and you've got different levels of skill and experience, and I'm kind of rambling here a bit, but there's always somebody at the bottom that always get calls up, you're level 3 or level 4 tech, it's the person who's like, well, we went through this, we went through this, we ran all these run books of all these incidents, and here we are. We have no ideas left. We need to call in the wolf, Winston Wolf. If you've ever seen Pulp Fiction, that should make a lot of sense to you. If you haven't seen Pulp Fiction, well, the wolf is the person when you call when you have a problem and you need it fixed and nobody else can fix it. That's the wolf. And usually that's the person, there's usually one or two of those people in any team, and they're always the ones that gets called. I know a few of them, and it's a lot of weight to carry on your shoulders. So wouldn't it be really helpful? Wouldn't it be really helpful when you get that HAR file, that 10, 20 gig HAR file, and you're just tasked with where do I start? What do I do? And the first thing you need to do, or I would need to do, or anyone would need to do in this case, is look at the thing, open up the HAR file and start trying to make sense of it. Start reading through it, looking through all the entries, and start going, okay, there's a request here, and then trying to not get confused with certain different requests and responses, and then looking at timestamps and trying to marry them up. And it's just that whole experience of trying to understand and trying to figure out what's going on with a HAR file. So what do I look at first? What request do I look at first? Am I searching a path? Am I looking for a query parameter? Do I need to look at a particular operation? Is that what? I don't know. So the point of Braid is to be that first port of call. It's like, I need to look at this thing. Braid will let you look at it. It's a viewer. It's a very fast viewer, or it's designed to be a very fast viewer. That's the intent of the tool, to make it go as fast as possible and be able to scan through requests and filter by method type, by path type, parameters, ideally, be able to do a quick search and scan. All these things, I'm not sure if there's a tool out there that does it. I haven't gone looking for it, to be honest, but I know that no one's using them. If they do exist, the people, the developers I speak to, the engineers that are solving these HAR file problems are not using them. So I have put together this idea. It's actually inspired by one of my colleagues. His name is Oscari, and he was talking about this, and also I was talking to another engineer that is actually already one of the hackers on Princess Beef, and is a contributor to another tool that we have, which is Wiretap. I'm going to go into this in a minute because it's important. And I was talking to him last night. His name is public anyway, so his name is Akash. Hi Akash, if you're watching this, or if someone's going to tell you that I've just mentioned your name, Akash Singh, he's already a contributor. Go check him out. Anyway, I was talking to Akash last night, and I was talking about this very problem because he said, hey, I'm on call at the moment, and guess what? I just got a big HAR file. And we were talking about, going backwards and forwards and using this and using that. And Akash said something to me last night that made me stop in my tracks and thought a little harder about what we're doing here for this hackathon. Just to make it more effective, to make what we're doing more effective. And he said to me, he said, Quobix, doesn't wiretap already do that? Here's wiretap. If you don't know what wiretap is, you know what? I've done enough. Big me here. Let's go to little me. Little me. So I'll get out of the way, and you can see everything that we're working up here. All right. So you can see all this stuff. Right. There you go. Wiretap. Wiretap is, it's basically a local compliance tool that you feed in. This is a little demo video here. In fact, if we go to Wiretap, look on the Princess Bee website, there are some videos. Quick start. There's a video here, and let me play it, but I'm going to turn the volume off. There we go. There's me. See that? There's me in a cowboy hat with a really patchy beard. That's why I've got the moustache now, because I can grow a moustache. I can actually grow a moustache pretty well. Look, there's me down in the corner. Hello. I'm wearing a hat, but see, I can't wear the cowboy hat with the headphones, so I've got to wear a baseball cap. And not that I don't like baseball, I will love baseball caps, but I will be wearing my hat if I could. Otherwise, I've got to wear earpieces, and I hate them in my ears all day long. They make them ache. And anyway, look, I've got less color in my skin in there. Got a different color balance. Anyway, what this is showing you how Wiretap is put together, how it works. It's a compliance tool that you would load in an open API file. Actually, I'll make this full screen. No, I'm not going to do that. I don't have no idea how that's going to affect the stream. I'm just going to leave it as is. But you load in an open API file and using the rest of the tooling, and then you would use Wiretap as a mock server, and you'd point your UI or your tests at that mock server, and you'd run it through, and it would basically either mock it, because you can use the mock mode. There's a mock mode in there which you would just replay kind of mocked, either from static JSON you provide yourself or generating it from the contract, or it'll pass it straight through to the real API. Effectively just tap into that stream of the requests and responses, and what it'll do is render the compliance, how compliant you are with that contract, so the requests and responses. Now, none of this would need to exist if you're doing things the right way, which is spec-driven development, contract-driven development, and then generating all the artifacts from that contract, like SDKs and back-end controllers and models and things like that, and documentation. If it's all generated from the contract, this tool doesn't need to exist. But that's not the case, and not the case nearly everywhere. There's the vision, the idea, the ideal is we do spec-driven development, contract-driven development, and then we generate all our artifacts. Now, we are starting to do some of that stuff inside Splunk/Slisco. Slisco? That's an interesting name, isn't it? Slisco. Sounds like it's interesting, isn't it? Slisco. Ooh. There's a parody there somewhere. Anyway, we are using this now inside my colleague, Roger Chickering, who's I'm going to say his name because he's another distinguished engineer that I work with, and he is building what we've needed, something that we've needed for years, well, for a very, very long time, and it's called API Gen, and it's an internal tool that takes libopenAPI and then does exactly what I just said. It builds out all of the SDKs and all of the controllers that we need and all the languages that we support, that we need specifically. So it's not like this is not generic at all, by the way. This is a very, very, very opinionated, highly specific implementation for our API surface and our API needs. It's not something you could use generically. It's not something you could use in any company. In fact, most companies do this. The majority of large enterprises, you will usually build their own implementation of whatever it is. That's why I focus on things like libopenAPI and small individual pieces that you can then compose downstream. I like to stay upstream with the atomic pieces and then let engineers do what engineers do best and build whatever it is they need to build with those atomic pieces. So that's kind of one of the fundamental mantras behind Princess Beef is, we do tools and they all work individually, but they can be composed. But the same applies with libraries and things like that. Anyway, this Wiretap video that's playing over here, back to sorry, I'm rambling all over the place here. I really enjoy it though. Oh, this is fun. I can't tell you how much fun I've been having with these streams. Like this is great. Getting it all out of my head. All the conversations I have myself when I'm walking around, on my daily walks through the forest, and I'm sitting there rambling to myself. Hopefully no one can hear me. But now I can just do it to you, internet land. I'm sorry, I didn't mean to slurp on the microphone. That must sound awful. I apologize. I do apologize. Let's do a quick check-in on the streams and see if that number is still 0. It's always 0, isn't it? I have no idea. I'm not paying attention to these at the moment, to be honest. I'm just having fun. I'm going to take a look at the Twitch. If I can find the damn thing. Is it live? Who's listening? 2 followers. No, 1 person. That's me. It's me. All right. Enough distractions. Let's get back to the point I'm trying to make here. So with the conversation I had with Akash, my mic keeps moving. I don't know what's going on here. I don't know why it keeps doing that. That is not me. I've got to keep an eye on that. Something is happening. Something is changing the volume. Something is changing the volume in the stream. I might need to reset it. I don't know. It keeps jumping up and down. Anyway, talking to Akash, and you can see here that there's all this, the API validation stuff is going on, but it also has another mode. See this? Half files with wiretap, and I've actually got the capability to read in a half file already in wiretap. And it will do validation on the HAR to make sure it's valid, and do a schema check and all that kind of good stuff. And then it will replay the HAR file essentially, but it will replay it in the UI. So here's the thing. This is the topic of the day. This is where we're going to make a decision and pivot slightly on what we're doing. While my wife is pinging me. Give me 1 second. Always loves to ping me when I'm in the middle of something. Always pinging me in the middle of my day. Doing things, busy, can't talk. With the HAR file, in wiretap, it replays it, but it will play it in the UI. So you'll see this, like if you're watching the video in the background, I don't know if you were or not, but the UI, you actually got the ability to see all those requests and responses. And it's not a million miles away from what we're trying to do with Braid, but they are different use cases. Braid is designed to be able to just look at the HAR file, scan the HAR file, understand the HAR file, was where you start your diagnosis journey. And then I wanted to upgrade it to act as a dummy server, so you could then ping it and see what it gives back. So here's a request, and you could see the response come back, so you could then test it, and test it out. And I still find value in that. I think that's something that we need to do because it doesn't exist in wiretap in the way that I want it to. But I don't want to start loading up wiretap with more functionality, because wiretap has a very specific purpose: open API compliance and mocking, nothing else. The HAR stuff I added in, but I think I'd like to focus more on just the viewing part for right now, because it's just having this conversation and kind of rubber ducking real time. Bear with me 1 second. I'm sorry, stream. I need to go and talk to my wife very briefly. I'll be right back. right. I'm going to double check something here because there we go. I'm just going to leave it like that. I think I've fixed the volume problem. I'm making some interesting mistakes today. Anyway, with today, the whole point that I wanted to open this opening spiel, this 20-minute opening spiel that I've been doing here, is I'm going to focus the stream. The stream. All discombobulated now. I'm going to focus braid on just viewing the HAR file. We're going to leave the proxying, sorry, not the proxying, the mocking capability, returning. Well, it's not mocking, is it? No. Hang on. Give me 1 second. I'm still being pinged. Oh, don't you love this stuff? I'll be right back. All right, back properly now this time. We're doing some building work, and there's lots of questions flying around, and I had to answer some questions. So I've answered the questions. Now we're going to move on. Focusing on braid, focusing only on braid, and focusing only on the HAR viewing, and making this good. So if you don't remember where we got to, when I say focusing on just viewing the HAR file, all the server stuff I'm going to leave to one side. So all the overlap with the wiretap, I'm going to put to one side for right now because it needs more thought. It needs more, and I don't want to cram this in. I don't want to turn this into something that we're, going to be running out of time on, or we do a half-baked job on, or it's not quite there. I want to focus on this. And that primary problem of what do you do when you have a HAR file? What do you do when it comes in and you're just faced with an unknown problem and you need to start somewhere? You need to start digging in and have something to dig into. Opening up that file in an editor is, if it's small, it's fine-ish, kinda. If it's big, it's not. If it's really big, it's absolutely not. And if it's like 60, 70 gig, I'm not saying that it's going to get to that size, and it might do. Actually, it could very well do if you're looking at tests and testing. But as a customer, probably not. If you're doing 60 gig of data through an API in the browser, that's pretty crazy. But you might be uploading videos, or maybe not videos. We don't do videos. I don't know, large logs, large CSV files. Anyway, it happens. I've seen them. We do get very big ones. So we're just going to focus on the investigation part. I want this to be an investigation tool, focused investigation tool for now, and then we're going to do the second part later on in another hack or hackathon, another session. Not this one though, because I really want to make it focused. Trying to do too much with one tool is always a problem, and it's knowing when to break the tool apart or break it into two and share common engines and common libraries. We're at this point, and I think this is just be a very focused tool for one specific use case and nothing else. I mean, you might want to, I don't know what else you would use it for. It only reads one type of file, and yeah, it's focused. That's what I'm going to do. That's what I'm going to go with this. We're going to just keep it focused. So we're dialing back the scope. We're dialing back the scale really of everything, and we can take some of those requirements out, so it doesn't have to have that server part. We can modify the design document with the AI today, and then we can move forward. So that's the pivot we're making on day 3, which is a good time. And it's not really a pivot, it's a reduction in scope. It's a clarification of what the tool really needs to be. The real problem, the mocking part, I'm sure, like once you know where to look, every developer is going to take a slightly different path from that point forward. But they all have that same initial problem. Where do I look? Where do I start? How do I look? How do I see? How can I search? How can I scan easily? And I'm hoping this tool will provide some of that relief, even if it's just for a few minutes. It's a few minutes of relief. If it does that, it's supposed to do that times 10, over time, and you've saved a lot of time and money, which is what we're all about. So, where to start? Yesterday, we managed to get, if I could bring up Terminal 2. I've already got Terminal 2 up. There it is. Terminal 2. This is us, the result of our work from yesterday. What we've got here is the ability to actually, scan. So this is, actually, let's just quit this. We'll quit. Clear so we can see. Let's see. All right. Clear. So we can run braid, view, test data, and this is a 5 GB file. And yesterday, like the kind of key design decisions we want is when you fire this off, it should boot immediately. You should see something, and it should tell you it's doing something. And I think we don't really know yet how to calculate how much time it's going to take to do the next part, which is effectively indexing. We need to index the entire half file without loading in all the responses, because they're massive. That's where all the weight comes from in a half file. So we can't load in those responses, and even the requests. We need to think about the requests as well. The request, any body, effectively any body can't be loaded, which means we can't do things like JSON unmarshalling using the standard library out of the box, because it's going to load everything in and parse everything, which is fine if it's a small file. Like if your half file is 10 megabytes, who cares? But again, that's not the use case for this. The use case for this tool is massive files, and we've got a test 5 gig one here. But so we need to index it first, and that means going through and looking through at that metadata and creating an in-memory map. That will still take memory, but not, so if our file is 50 gig, we're going to need 50 gig of memory plus to be able to make this work, which is insane. You can't expect any engineer to have a hardware with that much RAM available to them locally. I mean, sure, you've probably got a nice 64 gig machine, or even a 92 gig, or even 128. But not my 24 gig is average on a machine. We talk about machines, and it's even less in runners and things like that. So if you're running remote, not that this is actually designed as a remote tool. Maybe it should be designed as a remote tool. Ooh, a remote viewer. There's all kinds of interesting things to hack on there. Anyway, let's just focus. We'll focus. We've got a specific focus. Anyway, the indexing process right now, we can see on this 5 gigabyte file, it's taking about 13 seconds to index that 5 gig. And we'll see it right now, because this looks horrible. It looks horrible. But this is where we got to. We've got the spinner, we've got the loading the half file, it's building the index. About 13 seconds per 5 gig, which means it's going to be about 30 seconds give or take for a 10 gig file. And now we've got the ability to scan up and down, and any time that we load any kind of request and response, we're able to see that left and right. And we're only going to pull out that data. We're only going to start decoding that body once we know which one we want to look at, because we've got the index. We then seek in the file. We look at just those offsets and read the bytes, and that's it. So we don't have to worry about having, I think the benchmarks were 47 megabytes of memory, no more than 47 megabytes on the heap were used, when we are passing this 5 gig file. So we're not bursting above 50 meg for a 5 gig file. I'm happy with that. The thing I'm not happy with though, I'm not happy with 13 seconds. I'm not. I wanted to do better. So I started thinking more about this last night, actually. And I was looking at Codex, and I was sitting down on the couch. Actually. Let me reload this. Where's my conversation gone? Oh, why have you just... Hang on. I'm going to go over to Chrome here. Well, for some reason, my chat hasn't been picked up. But what we did talk about, I did explore, was looking at the indexing phase. So what I wanted to do was think about re-architecting the horrific engine that powers this indexing. And I wanted to think about, can we, instead of running sequentially through the file and then doing the indexing, is there a way we could parallelize that and do it asynchronously, so we could take chunks and figure out the chunks and have different workers effectively go off and do this indexing, so we could speed it up. And we went backwards and forwards, and really we're at optimum with our current indexing. The way that it works, it's about as fast as we can get it. Any other technique would require loading in that response body, or serialization and on a larger chunk, which is actually what the Sonic library does, which is much faster at deserialization and serialization in JSON standard library. So we can't use it. It's just pointless because we wouldn't get anything out of it. It's negligible performance, on the millisecond scale versus second scale, which is just who cares at that point. What is 1 more second to wait for a very, very large file to load. But we can cut that in half. I mean, I'd be very happy. 5 seconds on a 13 gig file. Pretty impressed. Five seconds on a 5 gig file. Sorry, I'm not sure what I said then. Anyway, so I went backwards and forwards, and really that's not going to be any benefit. So I was thinking more about a more performant decoder, because we need that same standard library JSON decoder interface, because that's the key in here. If we come in to our motor, and I'll go over to the code so we can see the code. Where's the Go code? Oh, I'm gonna need to modify my Stream Deck here. My button's broken because I changed the name of something. So I was pressing a button. It's like, it's not working. Now I can fix it. Okay, I fixed it. All right. So if we look at our motor, which is here, and index, I'll zoom out a little bit, it's a bit big. You can see in here that we're looking at the response content, and essentially everything really is we're using a JSON decoder and a token mechanism to be able to look through different tokens and then decode those individually. So, we're basically using this decode interface, which is something that we would need, that comes as part of that standard library. So we would need that interface to be implemented. And there is another option. There is another solution. There is another solution. Well, I say solution, is potential solution. It's something we've done internally. What is it? What am I going to say? Go 1.25 experimental JSON. I could spell it right. A new experimental Go API for JSON. this is something that's been in the works for some time, and basically there's a bunch of API deficiencies, like exactly what they've said here. There is a bunch of deficiencies in the standard library, just performance-wise. The API is a bit, and this is what we need here. See that we need this interface here to make our stuff work. Anyway, streaming is not great. Anyways, just there's a long list of problems. Like one of the biggest eye openers of the deficiencies of the standard library was case insensitivity on properties. That one got me. That one hit me in the face a number of times. When I was building vacuum, it took me ages to figure out what was going on, because sometimes it worked and sometimes it didn't. Like, why is this like it's, and it was, standard camel case definitions in properties, but sometimes they were loading and sometimes they weren't. I was pulling my hair out. And I think they even mentioned that in here about their case insensitivity. Case. Yeah. There it is. It's case sensitive in V2 in this new version of the JSON library in the standard library. JSON in the standard library, sorry. It is now case insensitive. Sorry, case sensitive, where it was case insensitive. Huge, real problem. Anyway, the thing that I was most interested in, the thing that I really want to play around with is this. So I don't care about marshalling. We're not marshalling anything. Nope. We're not doing that. It's the same. The V2 is roughly the same. Like, it's maybe slightly faster, or slightly slower. But this is what I want to play around with this morning. I don't think I want to do a code review yet with codex on any of the TUI stuff that we've built, because it is not right. It's not right. I'll just give you a fresh reminder of what it looks like. This isn't right. I don't want to review this code yet. I don't want to put any of this stuff in. I'm not even sure we've got the right elements in. It's really just a sketch to get us going. That's what I wanted, to get us off the ground, bumping on the ground. But I don't think this code is even close to review right now. I don't want to I've already committed it, unfortunately. But no, committing is important. And normally, look, I'll be honest, I probably wouldn't have committed the code in the current state. It just because, yes, it builds, yes, it runs, but yeah, it's horrible. Anyway, it's a good practice, and you should commit often. You should commit early. I tend to like getting a bit further into the sketch before I commit, and it's mainly because I don't want to pollute the timeline with a bunch of stuff. And yes, you can squash, and I'm just not that disciplined. I know there's a few people out there, like my friend Roger, who is very disciplined. He's a very disciplined man, and I'm not as disciplined as him. I wish I was. I'm too sloppy, too messy. In fact, Roger is the inspiration for something I'm going to be building. I haven't built it yet. I've built parts of it, and I built bits of it, and it kind of exists in some forms. But I'm going to be building a Roger mode into all of my tools. Roger mode. Roger mode is colorblind mode, and it's designed for, basically it's going to monochrome everything. Everything's going to be monochrome, because, grayscale, not monochrome, grayscale. So you can see things, but it's just not going to confuse you with colors, and it's not going, and it's a real problem. Like, it's a real problem, like color problem. I've got a number of friends, a number of people I've worked with who have color issues, who are colorblind, and they just can't see it. And like, my colors are like, all colors look crazy, and when you ask them to build colors, it looks crazy. So yeah, this is a real problem, particularly with men in engineering. There's more colorblind people than you realize, or people who are, see colors on a different scale and in a different way. So, Roger mode. It's coming. It's coming. I'm inspired by Roger because his plight is real. It's a real plight. And, you know, you've seen the white colours with the blues and the pinks. I mean, they obviously look crazy to someone like Roger, but, you know, I'm just thinking, what does that look like if you are colourblind? It must look like a total nutcase mayhem. Then again, all colours must look like that. Anyway, I digress. Let's talk about marshalling and JSON. We're already doing this. We're already doing this with our internal tooling. We're already using it, or we've got a flag for it so you can enable it. I want to try it out. I want to try out this new JSON implementation and see if we can shave off some time from that 13 seconds. In theory, all we should need to do is just import the new library as a drop-in replacement versus, you know, changing all this stuff, and enable it with the compiler, because it is experimental and it doesn't work unless you know have a flag in there. So we need to do that. But I think I'm gonna try it out. Let's try it out. What's the worst that could happen? Let's before we do that, let's make sure our environment is clean. Let's bring up tower here. Nothing in there. We have a go work and a go work sum. You know what? We're just going to exclude those because I don't want them ever being committed by mistake. So we're clean. All right. So the worst is that we just nuke our workspace. That's just the worst that can happen. The best that can happen is that we shave time off. This 13 seconds I keep talking about, it's here, it's right there, it's loaded in 13 seconds. We're loading 70,000 requests and responses in 13 seconds. I think we can do better with the indexing in 5 gig. We should be able to do better. But I don't want to over-rotate on this because we are going to burn time. But because we have reduced the scope, it does give us more time next week to be able to really focus on cleaning up the UI on Monday, Tuesday, and Wednesday. By the way, I'll be in the office in San Jose, streaming from the office. So I've got to find a nice, cozy place to do that from. Although that's not very easy in the office because it's all open plan and like hot desking and, you know, sit anywhere and it's yours, and, you know, everyone can hear everything everyone else is saying all day long. Can be pretty noisy and distracting. Open plan offices were one of the worst decisions the corporations ever invested in. Just so you know that, corporate world, open plan is a disaster. And we keep doing it because it's cost effective. But it's not very mentally effective. Everyone needs a space to work in quiet where they can focus. And headphones shouldn't be a requirement to do that. Anyway, I'll stop rambling now. Hopefully people agree with me. Maybe not. Maybe. I'm just going to take a moment here to make sure that I go and put the link in my Discord. I don't think I've done that yet. All right. Let's take a look. I'm just going to put this link into my Discord. Give me 1 second. All right. So, first challenge, not a code review. We're not doing a code review. We are going to enable the experimental JSON decoder and try it out. Let's try it out. Before we do that, let's compact the context so we're not going to be burning up. And we need to make sure we're model around. I think we're still on Opus. Don't need Opus for this. We don't need Opus for this. All right. So we're going to compact the conversation from where we were yesterday, and we left it off with having the agent build out the initial version of the terminal UI, which needs a lot of work. It is not good. It is not good, Claude. Your design skills are terrible. But you are very smart, aren't you? Very smart, Claude. Yeah, I really do want to see if we can just shave down, because I mean 13 seconds is not a huge cost. Of course, that is on my computer, and I do have I've got a M. Just so you know, I've got an M4 Max with 128 gig of memory. So you know it's got some horsepower, and I got the memory to be able to load in a 50 gig file if I wanted to. But that's not the point. The point is that we need to squeeze as much out of this rock as we can in terms of performance. And I don't think we're going to be able to improve upon our seeking. I mean, I'm sure there's an algorithm out there that I don't know about that we could implement that would, you know, speed this up, but yeah, I'm just not that clever. From a logical point of view, there's no benefit of going async. We'd have to start scanning the entire file to find boundaries and then delimiters. So we would negate the speed we've already got, essentially. There's no way to speed up that process, that particular process. The only way to speed things up is the decoding library that is actually doing the work for us once we've found which pieces we want to decode. And I'm under the impression that that is going to be something that we will get, because it says it's a 10x improvement, up 10x plus improvement on unmarshalling stuff, which is what we need, right? And take those raw bytes, unmarshal them. Now we're just waiting for Claude to come on, Claude, hurry up. Compacting the conversation. What model are we on? What model are we on? Oh, yeah. This is another annoying thing. Oh, there we go. Yeah, no, we are on Sonnet. Great, we'll just stay on Sonnet. We don't need Opus. All right, we are compacted. So let's start. Good morning, Claude. I hope you had a nice sleep. I did. I was thinking about this all night. I was thinking about the performance that we have in the Horrific engine. And whilst it's very good, I was thinking about, you know, potential ways to improve it and investigate it, parallelized. I can't even say the word. Let me change it. Ooh, you got it right. Look at that. Parallelized. It can spell it better than I can say it. Parallelized code. I can't get my I can't get that sound out right properly. Parallelized. Anyway, oh no, don't say anyway. Parallelized code. Running the index async, and I wasn't able to find a way to improve upon the algorithm that we've already implemented. It seems pretty optimal. However, as I was sitting there on the couch watching television last night, I had a thought about the potential of using the new Go 1.25 JSON standard library, the V2 version of the JSON standard library implementation. It's experimental. What I'm going to do is I'm just going to paste in the link to the Go Dev blog and ask Claude to go and read it. Can you go and read this blog for me in detail and take a look at the potential performance gains that we could get on the JSON decoder and swapping it out for our implementation of the current standard library for the V2? I want to try it out and see how well it would work. Can you build me a full diagnosis of what it would take to allow us to run this new experimental JSON standard library replacement alongside our existing code, and what it would take to just flat out replace it, meaning we'd be taking a dependency on it. All right, so let's see what happens. And Claude starts thinking, good morning. Let me read through the JSON v2 blog and understand the performance characteristics of how it would benefit the motors package and HAR processing. All right, let's see. Let's see, Claude. Excellent research topic. The JSON v2 experimental package looks very promising. Let me analyze the motors package current JSON usage and create a comprehensive diagnosis. Why, thank you, Claude. This is why we have you. This is, I get so excited every time I think about this. This capability did not exist this time last year. Not really. I mean, you could ask an AI agent to go, or you could ask any ChatGPT to go and look something up and summarize it. But to have then autonomous agents do something about it, build a report, build a prototype, compile it, package it, debug it, fix it. It's like you just like say, I want a blah 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 blah, a blah 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 blah. What's that from Big Hero 6? Blah 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 blah. That thing, that sound, whatever that is. Looks like. Did you? Oh, he did read the blog. He read the blog. Ooh, hang on a minute. All right, let's take a look. Let's see. Ooh, exciting. What have you found, Claude, me old mate? Oh, there's a lot of stuff in here. Okay. Let's zoom in just a bit more just to make it easier for everyone to see. That's annoying. It'll go to debug there, you zoom, and it jumps you to the bottom. All right. Not sure if you can see that. Should be able to see it. Comprehensive diagnosis. JSON v2 integration for the motor package. Based on my analysis of the motor package and the JSON v2 experimental library, here is a complete assessment. The high-level findings. JSON v2 promises 10 times faster unmarshalling. So, in theory, we could take those 13 seconds down to what, 3 seconds? Oh, it's saying under a second. Yeah, I'm going to say this now. Bullshit. Excuse my language. BS. There's no way this will be under a second. No way. But I love the confidence. Claude. You are very, very confident in that. The motor package has already got the perfect abstraction. Thank you. Part of the design, that hard decoder interface for swapping implementations. There's two approaches. A side-by-side. Oh, the token level API exists. Yeah. So that's right, because we built our own token code, and this has similar semantics. The motor package is already designed for decoder swapping. Thinking ahead here. Part of the reason why we do the planning, folks. Why we think about the planning and build against interfaces. Interfaces. I'll go back to what I said a few days ago from that Java book from 2003. If you don't understand interfaces, you don't understand programming. and I'll die on that hill. I will die on that hill because I believe it. I was offended the first time I heard it. You might be offended by it. You shouldn't be. You should be inspired. JSON v2 integration for the motor package. We've got, I already read that. The JSON helpers. This design is excellent for experimentation. Changing the decoder implementation only requires creating a new type, implementing the hard decoder, and updating the hard decoder to return it. I am super excited, and now we have the problems. Compatibility analysis. This might not be. No high-level decode. Critical finding: the token type incompatibility. JSON.token, JSON text.token. Okay. V1, the interface is limited strings, numbers, and bools. Bugger. Okay, so there is a little bit of work here. Some of the lower level mechanics are going to need to be swapped out. Yeah, we don't have this, so we're going to mix them up a bit. All right, so it's saying we're bringing the V2 decoder, and we'll implement all the interfaces and use all the new methods on the new decoder. We have to do a bit of hacking here. We're gonna have to effectively reshape based against this slightly. It's more powerful and it's more granular, and it uses a different approach for decoding the actual tokens. So it's a wrapper, really, or what we call it, adapt token. And then what else do we do? Keep the V1 as default. Yeah, that's good. V2. So yeah, we need to put the Go experiment V2 in there. Otherwise, I said, it won't exist in the compiler when it compiles, and we'll just say, "What are you talking about? This code doesn't exist. You're crazy." A little bit like when Codex yesterday was saying, "That code doesn't exist." Like, what are we talking about? You just when those models were composed, they're done a while ago. All right. Let's see what the advantages to this approach is. No code changes the core logic. Easy A/B comparison. We can fall back to V1 if V2 has issues, and there is zero risk. We can abandon everything if it doesn't work. I love it. Zero risk experimentation. When does that ever exist? Zero risk in experimentation. Disadvantages: the token adaptation overhead may reduce the gains. It actually might. So approach one is where we, all right. So here's a problem. If we do a hard decoder abstraction, rewrite index to use JSON text directly. I might do that in a branch actually. So let's do this. Let's implement the first suggestion, implementation approach one. So we do the side by side, which I like, and see if it does anything. If we can shave off even 1 second off of that 13.482 seconds, we should keep it because it's better. But then let's go further, and like it says down here, to do that full implementation plan, we are going to have to do a bit of surgery and essentially change how we're doing our tokenization. And we're going to use this JSON text, this new JSON text package that they've got in there for dealing with it. Yeah, like this stuff, like all of this stuff will need to be reworked, but that means breaking everything. And I'm not going to break everything and I'm actually really happy to take a dependency on the experiment. I don't think it's going to go anywhere. I think it's always going to make it in, but it might stay an experiment for a while. I'm okay to build the project with experimental code because it's a free tool. Who cares? No one's paying for it. And as long as it works, and as long as it works fast. I mean, it's got to work fast as we can get it. And I'd rather spend all my time getting it fast than making it pretty. Making it pretty is, it's an artistic process, and you've like painting. You can move things left, move things right, add a color here, align this, move this, add this, blah 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 blah. But this stuff here, I think, is getting it right, because once it's right, you forget about it and you move on. Then you start building other things on top of it. But if this part is wrong, like I know this because I've got to keep coming back to certain elements in libopenAPI because there's ghosts in that system because it's massive and it's complicated, and I didn't use existing JSON path tools out there. I built everything myself, and I didn't know what I was doing in some places. It made it work, but not great in some places. There's ghosts in there, and sometimes they come back out and play. And there's still a couple of ghosts in there that I can't track down. I don't know how to track down. I've tried for hours and hours and hours and hours and hours and hours, and they only come out, at very certain times of the day, in very certain orders and organization and sequences of data. Right? And they're unreliable. I can't reliably test them. For example, there's one bug that I can't recreate in any other document except for the DigitalOcean document. And there's a way around it. I've got a workaround, but DigitalOcean has like 1,700 files in it. And it's all exploded as a massive graph. Yeah, there is no enterprise bloat. There's no enterprise bloat. There's actually very little bloat in any of it. It's all pretty lean. There's some mess. And OpenAPI changes is a horror show. But there's some mess in there, but it's relatively clean. It's relatively lean and it's polished in the majority of places. LibOpenAPI has some ghosts, real ghosts. I just can't track it down. Anyway, I'm off in the weeds here. Let's get back to the experimental JSON decoder, and so that was a. If you're watching the video, that was something from chat from David Serrano, who's watching on YouTube at 9:44. And it's 6:44 in the morning. It's very early. Very early in the morning. You must be at the gym. Or making breakfast or something. Or in the office. I don't know. Alright. The critical problem is loss of byte offsets. The current motor relies on the input positions. This breaks the entire random. A critical problem, loss of byte offsets. Oh no. Okay. All right. And this is what I discovered last night when I was doing more investigation into this, is that we really are pushing it in terms of how fast we can run this. The problem, part of the architecture of this is that, the speed comes from having a massive file and not loading the entire file into memory. You can't. We've got to index it so we can do lookups, and we've got to figure out, where those bytes start and where they end, and then we read that when we need it on demand. It's the only way to make this memory efficient. Otherwise, who cares? 50 gig in memory, sure. And in 10 years time, this might not be an issue. I say 10 years time, I remember, what was it, 2015, 16 gig of RAM was like the standard on a Mac or a dev machine. 16 gig. And what is it now? 32 gig. So we might get up to 64 gig in 10 years of standard. And it's maybe doubling every 10 years. So it still doesn't solve the problem of you've got a 50 gig file and you want to load it in locally. So I don't know, maybe. But anyway, that's the future's problem, not today's problem. Today, I want to make sure we can go as fast as we can. What it's telling me, what Claude is telling me, is we actually lose all of that capability with the new decoder. Our custom work that we've done to do that scanning effectively will be lost. The same problem we would have using any other JSON decoder. No matter how fast it is, it's going to read in those bodies, or we don't have the ability to use that library to identify just that piece to decode. So we're it doesn't matter which way we shove it, it's not going to work because it's trying to do everything we're trying to avoid. Now, what it is saying is that there is a place where we can compromise and maybe use it. So the indexing phase, we use v2 for the metadata parsing. And it's saying we don't have the offsets, which is, I guess, a big problem. And then it's saying user track the offsets manually with a wrapper. So we're going to basically wrap it. We'll keep the offsets in that struct as the wrapper and then use the underlying library. We have an offset tracking reader, our new JSON text decoder. So we use the JSON decoder for pulling out the metadata that we then stick into our index, which runs in memory. Dependency. Okay, look, it's not much work. It's really not much in terms of just wrapping it around and keeping this stuff here. It's the offset that we need to track. And that's the piece, that's the critical piece there, is you read this much up to this point, and that's when the offset gets set. So dependency analysis. How do we add it? How do we add this? We need to add it to our Go mod. Well, that's obvious. And then we actually need that flag, the build, the Go experiment equals JSON v2. You cannot ship. Oh no. In production. What's this? That's new. I haven't seen that before. That's new to me. Let's take a look. What's this? Oh yeah. So okay, this is nonsense. This is nonsense. This is enabling Go experiments. Yeah, okay. I'm just yeah, all right. Ignore that, everyone. We're not going to get this 10x. We're not going to get the 10x. Best case scenario, using the new v2 API, could achieve 7.8 if we solve that byte offsets problem. So we could speed it up by 7 or 8 times by using the decoder if we track the offsets ourselves with the wrapper. All right. I love these. Like, this is how long it takes. This is how long it thinks it would take to do this work. 2 to 3 hours for the feasibility test to build all this. It's not going to take 2 to 3 hours, is it, Claude? No. And then phase 2, side-by-side implementation. Phase 3, optimization. If the results are promising. Phase 4, production decision. If it's less than 2 times speed up, delete it. If it's 2 to 4 speed up, consider for future when the V2 is stable. If it's 4 times the speed up, it's a strong case for release. You know what? Let's just. I'm gonna branch. We'll just do it in a branch. Save ourselves some pain. Let me bring up tower. Still didn't add a button for it. I need to add a button for it so I can show you. I'm going to jump to it easier. Let's create a branch, and what should we call it? We'll call it it's not showing. That's an interesting thing as well with this tool. It doesn't show the modals that come over the applications. There's a modal over my application right now in Tower. It's telling me what branch you want to create, but you can't see that on the stream because I'm not showing my entire window. I'm just showing individual windows because my monitor's like 4 miles wide and it wouldn't work. Like you wouldn't be able to see anything. Let's call it Jason V2. Very, 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 very clever name there. Jason V2. Let's run that in here. Now we can go back to our terminal. And it says phase 1. Let's do up to phase 2. Let's do no. No, Claude, I've just branched everything off into a new branch, so please go and implement phase 1 and phase 2, please. Let's just do this and see if it works. Off you go. Now let's see what happens. Apparently it's going to take how long? 1 day and 3 hours. And it's saying that we could get up to 2 to 3 seconds. A 3 to 5 speed up. And it's saying we lose even less memory. Okay, that's, I don't know where that came from. That's made up. But we could shave off a lot of time here. If we get this down to 2 to 3 seconds, I don't know what I'll do. I was going to do something silly, but I won't do something silly because I have to follow through with it probably. I won't do something silly. I don't know, we'll have a celebration of some kind. I'll have a celebration. All right, let's see where we are. Oh, yes. Yes, yes, Claude. Yes, I want you to run it. Run it. Go and do it. Do it. Do it. Do it. Do it. Yeah. Let's do it. Let's do it, Claude. Running a test suite. Just add all the JSON helpers. It's changing them from runes to casts. And that's about all I can see without digging into it. A comment from David Serrano on YouTube. If you get to 2 or 3 seconds, you should celebrate by asking for VC money. Well, there is just 1 or 2 small problems with that, my good sir. The first problem is that this is a free tool. It's MIT, is going to be MIT licensed. Second, it's for an internal hackathon at a corporation. So even if I say, okay, this is so good, we can extract value from it, it would belong to Cisco because I'm building it on Cisco time for Cisco. So yes, not that it's not commercial, so it doesn't belong to Cisco, it belongs to me. But if it was, it would have to belong to them legally. If it was for money, there's no money involved. No money. No money. This is free and open for everyone. public domain. Kind of. Not really, because it is a copyright on the top. You can't take that off, but you can do whatever you like with it, the rest of it. All right. Claude says, perfect. I'm using a hybrid approach. V2 for fast token passing, V1 for struct marshalling. Let's test. It doesn't work. Yay! While Claude is doing that, let's come back over to another comment from David. I can't take the copyright off, but I know my AI tool will scrape it. What do you mean scrape it? Yeah, it will scrape it. I mean, yeah. It's another interesting dimension in all of this is when I'm running Claude, it often gets all the dates wrong. And it mixes and matches up random headers from random different, it's all these 4 or 5 different styles, and then you should be careful with that if you're generating headers. But then there's the reading of it. When it's reading stuff in, it's also going to do the same thing, but in reverse. It's going to read those headers in and get it all mixed up, and then start creating maybe interesting stuff. I don't know. It's all uncharted territory. Really, really uncharted territory, not, pretend uncharted territory. Right. I won't go into it. I won't go into that one. I'll leave that. We'll move on. And what was I going to show you? I'm running on this. Yeah, I'm on my other terminal. Exit, clear. While we're waiting for Claude to do its thing, let's check in on the usage. How we doing? Since the 12th, okay, so for a couple of days over the month, we have accumulated nearly $1,500 of use. If we were paying for the API, which we're not. Got the max, Claude Max, Code Max, Claude Max, whatever it is. Let's go back to the OG. This is where it's now getting confused. Oh, I'm sorry, I made a mistake. Oh, I'm sorry, the issue is, oh no, oh, I'm sorry, oh no. Now let's actually see if it figures its way out of this mess. Or if we're just going to delete this branch and get on with our lives and just chew up. Oh, hang on, measure the index, which we already see is 2.7x. Oh, hang on a minute. V2's buffering causes different offsets than V1. The simplest solution for phase 1 to measure the V2 index and speed up. No, it's not. I asked you to build it. You're backing out now. You're backing out, Claude. That's not what I asked you to do. I said build it, and now you're saying, oh, we'll just let me do a summary. I can do a bit of it. But it's hard. It's hard. Yeah, I know, Claude. It would take days to do this manually, to unwire it and rewire it, and it's like, it's a lot of work. But it becomes somewhat trivial, when we've got AI. It doesn't have to do it properly, not yet. But this is interesting. This is running the benchmarks. Come on. Failed. It's almost coffee time. We are 1 hour and 26 minutes into the stream. And I am out of coffee. What we're going to do, excellent, I have concrete benchmark results. Let's create a summary document of our findings. Let's see what happens, let's see. And then I'll take a 5-minute break to go and get my coffee, top up, and we'll get back to it and either throw it all away or we're going to bring it in and merge it to main after a code review. Perfect. You're absolutely right. You're absolutely right. All right, let's see. What have we got? What came out of the chaos machine today? JSON v2 integration phase 1 and 2 complete. I don't know if you say it's complete. Come on, just lying to me. You're lying. All right, the file sizes, we got all of them projected. $5 MB file. .3 milliseconds. 50 MB file. 74 milliseconds. So look, that can't be right. 500 meg, it takes 742 milliseconds to scan. Come off it. Basically split it in half. %, fewer allocations. Massive reduction on the garbage collection that we were seeing. If you think back, maybe you weren't watching, but on the day one, I was wrestling with the amount of GC that we were running on this. We were in our experiment, if I remember correctly, it was about 600 GC cycles. We didn't burst the heap beyond, for 5 gig, by the way, it was 5 gig. We didn't burst the heap beyond 50 megabytes. We didn't burst beyond that. It was 47 meg, I think, that we peaked out on the heap. But we were making 60 gig of allocations, which bothers the hell out of me because it means that the GC is constantly going to keep that memory clean and reducing the heat pressure. But if we can, like this says 73% fewer allocations. That's massive. That's the thing. That alone is worth it. 8.5% less memory usage. Love it. It hasn't done the 5 gigabytes. Why not? Current status working. Oh, okay. Known issue. Oh, this doesn't work. Well, how do we know these results are accurate then? Index test passed. Readout test. Oh, the tests fail. Oh, I don't care about the bloody tests. All right, let's see what this says. The next steps and the recommendations. Option 1, ship v2 for indexing only. Option 2, fix offset tracking, more work. Option 3, wait for Go 1.26. No. Why can't, yeah, okay. So yes, please test with the 5 gig file, and then I want you to test the option 2. We're working on this, Claude. There's no waiting for... We're not waiting for Go 1.26. We are trying to experiment with the absolute fastest way to get this data done, and we're going to ship with that fastest way. Whether that is this way or we delete all of this and we go back. I need you to look at that offset problem and figure out what we need to do to make it work efficiently and cleanly. I think Claude suffers a lot from what we see, you know, with a lot of engineers. Is like, well, I've done it, I don't want to do it again. I've already built it, don't make me undo it and do it again. It's fine, just leave it the way it is. I don't want to undo it. No, undo it and do it again. Hello, Kei Yuhara. How are you? Nice to meet you. I hope I was saying your name correctly. I'll just call you Kei for now. Do we want to proceed? Yes. Yes, Claude. How are you doing? I am doing well today on this Friday, November the 14th. Doing well today, Kei. Hope you're doing well too. Do you want to proceed? Yes, I do want to proceed. Once we achieve a landing place with this, or a decision point, we are going to well, decide whether we're going to pull this in, and then we're going to move on. And I'm going to grab another coffee because my coffee's all gone. It's all gone, so it's empty. You see that? Well, you can't see it because it's a black cup, but I'm telling you now, it's empty. There's no coffee in there. Well, there's a little bit of coffee. I tell a lie. There's a little bit of coffee. A little bit of coffee. Not so bothered about the test right now. Test can fail. 2 times faster. Yeah. Yeah. This can't be real. It can't be real. Maybe it's real. 762 megabytes a second throughput. It was taking 13 seconds before. We're down to 6.7 seconds. If that is real, if that's real, I need to thank you, Kay. The comments is keep making videos. I love your videos. Thank you very much. I really appreciate that. And I've got a nice setup. NGL. I think that means not gonna lie. I hope so. I hope it means not gonna lie, or it means something else. Maybe it needs something else, or nice green lights. No, I don't think it means that. Maybe, but thank you very much. It's very kind. Let's see how Claude does with this experiment. Yeah, well, so you're right. So that's Francois, my good friend Francois. Hello, Francois. Thank you for commenting. It is less than 10. It's less than 10 for a couple of reasons. We're not using it we're not using the entire feature set, and 10x is what the blog was promoting. You know, you can get up to 10x improvement if you're using it, you know, like as a drop-in replacement. Before, we're not actually doing it in a sense, because we've got a 2-pass design in Braid. The first pass is the indexing, and that's where we need all those offset problems to figure out, you know, where does this JSON entry contain the request to the response body, and we don't parse or read that, which means we're doing kind of tokenization on each piece. And if you're marshalling in the entire object, it's faster because the algorithms and the rebuilt the engine is all faster. But we're only kind of using bits and pieces of it, so we're not going to see the full speed up. But using the decoder and just decoding using this JSON text package that they've implemented, I haven't read the code, I don't know how it works, but reading the docs, it's an improvement. It's more granular control over actually parsing those tokens. Oh, here we go. Look. Oh, wait. I see a fundamental issue with tracking token sizes. The white space between tokens isn't accounted for. Okay. Let me use a different approach. All right. It says it's cleaner. It says it's cleaner. Not sure if it is cleaner. Actually, let me try a much simpler approach. I'm going to track the raw bytes consumed by wrapping the entire entry parsing in a read value call. This gives us the... Hang on. Oh, don't jump. I haven't finished it. I haven't finished reading it. Oh, no. Wait. I'm overcomplicating this. The solution is even simpler. I don't know what it's doing now. It's gone into full Claude mode. It's full Claudifying whatever on earth it is doing right now. I have no idea. It's index routing. What are you doing? I don't know. I don't even know what it's doing. It is creating a mess, aren't you, Claude? You're creating a big old bloody mess. We can clean it up. It can all be cleaned up. All of it can be cleaned up. In theory. In theory. It was an interesting sound that just appeared somewhere in my room. Not sure if you heard that or not. Don't know where it came from. It came from behind me though. You're the only one watching? Yeah, unfortunately, Kay. You see, I've only just started doing this and don't really have much of a presence or a following on it. I haven't really done much to facilitate that. I'm hoping that would change over time. Should change over time if I keep going. But yeah, right now it's yeah, definitely not one of the cool kids yet. Definitely not one of the cool kids. Just, practice and producing high quality content. That should change things. It should change things. But you never know. Okay, let's see what Claude is asking us here. It's building a new index. It's passing from raw. Now I'm getting afraid, a little bit afraid that we are messing things up, and I simply don't believe what it's telling me anymore. I've lost faith. I've lost faith completely. I'm hoping the Claude can bring it back around and prove me wrong. You never know. I've been here many times before when I'm just thinking, what are you doing? What are you doing, Claude? Oh, you're going to go format. Yeah, okay, that's no big deal. We just need to keep going. Keep going and keep plugging and keep smacking it with a hammer until it starts working. That's actually the secret to most software engineering. Most software engineering requires just keep hitting it with a hammer. Just keep hitting it. Keep hitting it until it works. Bang, no. Bang, bang, no. Bang, 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 bang. No. Elbow drop it. No. Kick it. Drop kick it. Ah, that worked. But why? And now you know how to program computers. Just scream at them. Shout at them. Type angry. Really angry with very hard key presses so the computer can hear you. All right. What are we doing here, Claude? Given we're approaching token limits and we've proven the two... What token limits? What token limits? I realize I'm blasting plosives at my mic. It's supposed to have a built-in pop shield. It's not working very well. Well, it doesn't work very well. So I've got a big fluffy windbreak I can stick on that. It's coming today or tomorrow. So just get rid of the big plosives happening there. It's saying that, let me take a pragmatic approach. I'll commit what works. No, you won't commit anything, buddy. I won't commit anything. I'll commit what works. The indexing speed up with position tracker. The document and the offset issue is a known limitation requiring more investigation. The 2x speed up on indexing is already a huge win, worth shipping. All right, let me test if the V1 build still works. All right, so what we've done is it says we've successfully proven that JSON v2 provides a 2x faster indexing, 6.7 seconds versus 13.5 seconds, which is exactly what I wanted. Exactly what I wanted. I wanted to cut that in half, which is a massive win. It is a massive win. What works? Indexing, throughput doubled, clean build tag, V1 remains fully functional. The remaining issue is the v2 parse entry from raw function has a syntax error that needs fixing. Once fixed, we need to verify that the offset tracking works. The core solution is in place using position tracker to count actual bytes read. One. I would like you to fix the bug, please. So the question from Claude was, what would you like me to do? Commit the code? No, I'll do that. I don't want you to do that, Claude. What I do want you to do is fix the damn bug. Fix the damn code. Fix the damn code. Please work. Come on, we've already built it manually. We've already built it manually once. We don't need to reinvent the wheel. We already know how this works. We already know how it works. Just make it work. Do the job. Build the test. And then we're good to go. Ah, look. Errors. Excellent. Indexing works. Now let's test the critical part. Reading the actual half file when we need to, doing those offsets. Error. Well, you said something and then you pushed out a bunch of code. The offset tracking is still wrong because tracker.pos tracks buffered reads, not parse position. Let me fix this properly by calculating offsets from cumulative length of parsed JSON. Okay, we're kind of off into madness world again. I don't know what it's doing. I don't know what it's building here. Calculate length prefix. The prefix is log entries. We need to calculate the exact byte length, including any white space for now. Use a simple heuristic scan to find this pattern. Anything in between this. Okay, that makes sense. Yeah. Oh no, you deleted it. Oh, you went and deleted it. Why did you delete it? I'm reading it and then you're removing it. I don't know. Nebulizing. Actual JSON bytes consumed, not the buffer. Important, JSON text decoder buffer reads. So tracker.pos equals parse position. We need to track the consumed JSON bytes manually. Yes, we do. We've been trying to figure that out. Oh no, let me take a pragmatic approach. The core issue is that the buffered IO makes offset tracking complex. Since we've proven V2 gives us 2x faster indexing and V1's readout works perfectly, let's use a hybrid. Okay, I'm fine with that. 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 Just want the indexing. I don't care about the read. The V1 read is fine. The indexing is what we needed to speed up on. That's the pain point. Let's go from there. I'll be back in just a moment. I'll be right back. All right. Let's see. Okay, the final results. Yeah, we haven't made any progress on this. The remaining issue is the offset tracking, and it's a problem with experimental doodah. It's fine. It doesn't matter. It doesn't matter because we've already got a working version of V1. It's V1. It's not V1. It's just in main, not V1. What are you talking about, Claude? It's saying the position tracker counts bytes right in the buffer, but the JSON text decoder passes from that buffer asynchronously. Another design complication. So when we record the tracker deposit, the .pos, it includes unparsed buffered data. Okay. F, marry, or kill. Claude, Codex, or Cursor is a question from David Serrano. Kill, Cursor. F or marry, Claude or Codex? I'm gonna marry Claude, and I'll take Codex to Vegas for the weekend. Yeah. Vegas for the weekend, the Codex, but Claude. Yeah, that's who I would marry right now. I would. I've tried Codex for days on end and it's still not, it doesn't feel, just doesn't have that same feeling. Just doesn't feel the same. Works okay. Works, I mean, great for code reviews. In fact, I really enjoy working with Codex on a code review. We haven't done any code reviews today yet because we're experimenting. But when we do some code review, we will do some code reviews today before we move back on to visual stuff. And now that I've reduced the scope, we can spend more time next week doing visual stuff. But today I really want to kind of come back around. Now we've got the foundation of the quobix CLI. We've got the foundation of a bubble T terminal. I really want to focus on performance and getting this part right, because I got to get that. I've got to get that indexing down by half. If we can get it down to 6 or 7 seconds for a 5 gigabyte file. Yeah, I'm okay with that. I'm okay with that because and then I want to just get the numbers for the smaller files. 5 gig is kind of at the upper limit. I'd like to get a 10 gig as well, but I think that's going to be towards the super upper limit for the majority. We're probably looking in the hundreds of megs, and we're going to start doing some benchmarks there for hundreds of megs. Because that's where we're going to see the majority of use. Another comment from Mr. Serrano. Codex is definitely that Vegas weekend trip. He's got a lot of money he can spend on you. Yeah. Yes, Mr. Altman got a lot of money. Well, he's got access to a lot of money. He's got access to vast amounts of capital. Or at least that's the perception that they've given the public. The reality might be very different. All right, so Claude is saying the V2 implementation is accurate indexing, and we've already discussed because we've got the asynchronous problem with JSON text decoder. We can't use it for actually doing the scanning. I mean, not the scanning, the reading of the pre-scanned index. We can't read that chunk using the new API because it's messing up. So hang on a minute. Let me read this. Give me one sec. I don't think I'll worry about option 2. We're just gonna do one. Let's implement option 1. We'll leave option 2 for another day. I'm happy with that 2-term speed up. I'm going to take the win and move on. We've got other things to do. Can you please clean up the code, run the performance-code-reviewer on everything, and get everything ready for a full code review for me? Let's see what Claude says. Deleting a bunch of tests. Oh, what are you doing? Yeah. Well, actually, before we do a code review, I'm just going to make sure it's all working. Then I'm going to run it. And then we're going to see. We'll run it real time. And if it does say 6 seconds and it still operates the same, what we've been going for about just under 2 hours now, it would have been totally worth it. Totally worth all of it. All of it. The entire experiment. And then we can bring that hybrid approach where we're using partial experimental decoder for the indexing run, and then we're just using our V1 code, which is just straight up reading from a tokenizer. So now we're going to mix in this experimental code to make it run faster, make the machine go brrr much faster. The computer is going to go brrr. Faster string decoding, because that 6.7 seconds for a 5 gig file is more than reasonable. It's impressive. It's impressive. But then when we think about the average size, let's just say 250 meg, or I don't know, I need to get some averages on this, but I know the tests were running in the gigs, 5 gig, 10 gig. So it's probably smaller, much smaller for an actual, I need to get some numbers on that. But let's just say it's 500 meg. It was saying it was passing that in nanoseconds. I don't believe it. We're going to try a couple of those, and then I'm going to get some more coffee. This is still empty. I'm coffeeless. I drank it all. I drank all my coffee, and now I need more. Here's our performance code reviewer doing its job, cleaning up the slop, cleaning up all of the mess and the goop and the slime. AI slop everywhere. Percolating. I think it might be done. Maybe not. Maybe it's now going to take in the feedback from the agent, and then the other agent's going to go, "Oh, you're absolutely right." What did you say? He says he's going to say he's got absolutely right, isn't it? Say that again. You're absolutely right. Absolutely right. We don't know if we're absolutely right. But that's what they're probably saying to each other. Perfect. Perfect. You're absolutely right. Excellent review. Let me fix all the must-fix issues right now. Let's clean up that mess, shall we? Claude. Offset tracking reader is no longer required. No, that's true. We don't need all that. You've got to delete all of that stuff. Adapt token to V1. Ooh, gonna have to rename some of this stuff. We have to refactor this when we get into the code next week. Have to refactor that, that's for sure. Yuck. Yes, obvious pointless tokens. Comments, not tokens. Well, they are tokens really, but they're comments. And remove the error handling. Pointless error handling or unnecessary error. Overly concerned about micro errors that are impossible to test the majority of the time. This is another thing that bugs me, is when AI is building all of these branches. Like, can you even test that code? Like, why do that? You can't. To test it, you're going to have to cause a series of cascading errors that will be caught before you can ever get to that one. That's actually one of the benefits of thinking about code coverage. When you are trying to like cover the code and you look, it's like, how am I gonna test this code? How do I? You know, it makes sense. It's logically complete. It's catching a condition that may occur. But how can you trigger that condition? Yeah, there's always that. Well, you never know. It's like, well, maybe you should think about that a bit more. Why and how can you actually trigger this? And how would you test it? More importantly is, how can you write a test for it? How can you actually simulate this happening? And when you find yourself creating all of these hacks and injections and bypasses, and essentially you're bypassing all of the other protections that would be in place to catch code failures, and then you run a test and then you can test it. It's like, whoa. How likely is it that, you know, a model is going to fall through every single one of those latches? It's like having a very specific key that will only fit this shape. And if you can't build it going through the recommended design or your own design, then without, you know, injecting and bypassing and hacking it, then you shouldn't test it. Like, you should get rid of it. Delete it. Delete the code. Delete it. You shouldn't test it because it shouldn't be there. And I've actually had this quite a bit in some of my other tools, where, you know, I'm actually finding myself having to keep the coverage up. I'm testing pointless code. Errors. I'm catching errors that are so hard to trigger because they're functions, but those functions are used in a composed manner from, you know, 4 or 5 different nested levels deep. And to fire that, it's impossible in a normal running of or normal a normal operation of your application. Excuse me, I got my words all mixed up there. That happens more than it should as well. Used to drink alcohol. That didn't help. I don't do that anymore. Code review ready. JSON v2 integration complete. I don't believe you. I don't believe you, Claude. Critical and high priority. All fixed. All fixed. And this is all of the... This is why I have that agent. Because it's cleaning up this stuff. Removing the dead code. Comprehensive error handling. Obvious comments. Unused imports. Syntax weirdness. Anyway. Now we've got a hybrid V1 and V2. The V2 is only for indexing and provides a 2 times speed up. I'll take it. I'll take it. V1, standard library for use the read out operation, which is just actually once we've picked a request and response, it's just to go and pull that stuff out. That's a single entity. It's a single request and response. It's never going to be more than a few meg at maximum. You might see some very large payloads, but I don't think we even have the majority of these. In some products, you might have a very large payload, a very large payload. But bringing that into it's much easier to do that. And I'm not worried about the performance there, to be honest. That performance is you won't even notice it. I don't even know there's a way to, speed that up. But the indexing speed and performance is paramount. Like, that is what makes or breaks the usefulness of this tool. Because if you're sitting there forever waiting, or you do have a big file, big file, so like 200 gig. Buy, I don't know. I mean, that seems a bit big for me. That seems a bit excessive. But let's just say it does exist. We want to be able to at least be able to respond in a meaningful rate. We've opened it up and it takes 30 seconds to parse it. Okay, that's reasonable. Or index it, sorry. 20 seconds or 30 seconds to index a 200 gig file. Is that slow? I don't know. Maybe not. Maybe it's really fast. Anyway, the only real metric that matters on all of this is how it feels. Is when you're actually using it. Does it feel snappy? Does it respond quickly? Does it react when you say react? Does it do what you want it to do without going, let me think about that? If it does that, BS. Get rid of it. Doesn't matter how clever it is. Doesn't matter how cool the technology is. Doesn't matter how zippy you think the underlying whatever it is. Doesn't matter. And this is actually a really important lesson that took me a very long time to learn. Is nobody cares how clever and smart your code is. Nobody. What they care about is, does it do the job that you said it's going to do? Does it operate correctly? Does it feel like it's been thought through? Have you thought through the user experience of operating this piece of software? Whether it's from a developer point of view, or a headless point of view, or a CLI, or an API, or a UI, what is the experience of consuming it and using it? And how easy is it to get up and running? And is it effectively self-service? Can people operate it without needing you to be there? That's the benchmark for me. Is it just something you put out there and it just lives its own life because it's so self-documenting through its operation, or you've provided really clear, crisp documentation, as self-service information? That to me is the goal, the utopia, where it feels put together. I don't have to go searching for everything. If I do want to dig under the covers, it's all laid out for me. I fall in love with tools like that. I fall in love with them like that. Like Hugo is a great example of a tool I just fell in love with. Cobra CLI, same author, funnily enough, same author. Just the thinking behind the experience and how to use something. And sure, there's things I don't like about it, but there's things that people don't like about my software. But they like more bits of it than they don't like. And I like more of Hugo than I don't like. And there's, things everywhere you wish were slightly different, but that's the design. And You know, with open source, you can make your own. You can change it if you want to. Anyway, I'm rambling here because we should get back. It says it's all done. This is all good. Modified files, usage, build with V1 default, build with V2. I'm going to do this. I'm going to take this risk assessment, low, ready to merge. All right, okay, Claude, okay, let's try this out. Let's give this a go. Let's build it, and then we'll run it with a 5 gig and see what we see. Okay, we're built. Is there a file? Is there a file called recording.har in here? No, there shouldn't be recording.har in here. There'd be test data. Let's rerun our command that we had up here. Okay, we're loading. I'm not seeing 6 seconds. Well, fudge me. Fudge me with a stick. .36 seconds. We're at 13, nearly 14 seconds. Now we're at 6. For 5 gigs. Amazing. Oh man. That is a win. That is a win. Because I thought about this. There's definitely something we can get out of this. There's something in there we can use on the decoder because it is faster. Can we get full use? Maybe not. But we have just cut a passing time in half in 2 hours. All right, with that win, we're gonna do a code review and a comeback. I'm gonna go and get more coffee. I'll be back in 5 minutes to do a code review, and then we are going to merge this in, and we're gonna move on with some creative stuff. Actually, we'll make a bit of progress on the creative design. Next week, we're gonna start thinking about searching and filtering and ordering and all kinds of gooey stuff like that. But we're going to do some code reviews soon. We've got a whole bunch of code that was written as this sample for braid. It's our sample here. Oh, look at that. We got a problem. Okay. Let's say this. While I'm getting Claude to fix this, it's not ready to merge, mate. Not at all. Hang on. Hey Claude, my old mate, you said we were good to go. Now, I will admit, I am very impressed with that 2 times speed up. That is something special. I am very happy. But there's a problem. When I hit enter and I went to load one of the entries, I got an error. This is the error. Is it error? Failed to read entry. Failed to decide entry. JSON cannot unmarshal JSON string to go type .entry. So, we have a problem. I shouldn't be typing. There we go. So, we have a problem. The problem is that our V1 code for reading isn't working like it was. We should keep that code. It worked great. The indexing is great. Don't change that. It works excellent, and I'm very happy with the result. It is a massive speed improvement. Thank you. But we need to fix the loading. It should work like it worked before. That code was good. Let's make sure that code is operational. The next thing I'd like you to do is what we're going to do is we're going to keep this, and this is going to be our structure. We're going to go with the hybrid approach where we have the V2 for the indexing and the V1 process for just loading that entry once we've decided which one we want to do. That's how I want it. So please make sure that we don't mix and match all these different files. I'm going to want you to replace the V1 indexing with the new V2 code. That's the code that's going to go in and get merged. And then we want to keep the V1 entry loading. So, but we got to fix it first because it doesn't work. Please make the changes. Make sure the tests work for real, because it loads and it compiles and the index works, but as soon as we try and load, it's failing. And then please rerun the performance-code-reviewer to make sure that we have a clean file system as well as a clean surface ready for review. Okay. While Claude is going to go off and have a good old think about that, I am going to go make a cup of coffee. That means I'll be gone for about 5 minutes, and I'll be back in about 5 minutes. I'm not going to put a time because I've done that a few times now, and I come back a little later and it just it looks terrible. I'll be back. That's another problem. Is it doesn't matter how many times you say yeah, just do it. It's still should I do this? Can't fully walk away from it yet. What we need is, you ever see The Simpsons where Homer Simpson has his little red bird and he's at home, he's working at home basically. He's working at home, working remote. He's one of the first remote workers at the power plant, Springfield Nuclear Power Plant. He's becomes a remote worker because he gets too fat and he has mobility problems. Eats and eats and eats. He's really fat. Wearing a moo-moo. Working at home because he can't. Oh, that's my stomach growling again. It's that time of the day. And it starts going, you haven't fed me yet. Index types. I'm just going to have to assume you're doing something right here, Claude. I don't know what you're doing. I'm changing everything. You're changing everything. We already reviewed all of this, and now we're ripping it all up. For good reason. Not going to stand by and let those 6 seconds escape me. I want them. It sounds like my Alexa is alarming me, telling me that there's a package here. I'm not sure if you can hear that or not. I'm not sure if the mic can pick it up. I heard it come through the mic, but is there some kind of noise cancellation that's removing it? Probably not. Probably not. Delete, delete, delete. Keep deleting, Claude. Keep deleting. Give me those 6 seconds. And then I want to do some more benchmarks because I want to bring it down to the reality of, what are we actually looking at here? That 13 seconds was for a 5 gig file, but what are we really looking at? Is it going to be second? Milliseconds? Ooh. Then let's take a look at how big the binary is out of the gate. Let's just, bring up terminal 2. There's our error. Let's quit out of that. What we got? .4 meg. Now that is unoptimized as well. We can probably squeeze that down to 5 megabytes. That's nice. I mean, I don't know it's going to be 5 megabytes, but we've currently got all the debug flags and stuff in there, so we can just strip out all the debug symbols and all that kind of stuff from the using the LD flags. We change that, and then we get the smaller binary. Compress that down. Tiny memory, tiny footprint, big files. Ooh, that could be the slogan that we put on the README. Tiny footprint, tiny memory, big files. I love it. Yeah, I love it. Tiny footprint, tiny memory, big files. Yeah, that's fun. Braid. Maybe we change it to horrific because we're going to focus. No. I keep yo-yoing on, zigzagging on this name, whether I want to call it horrific or braid. I mean, horrific is, I don't know, but maybe I can reuse the braid name as something else. is that I keep talking about, the fact I keep coming back to this. Right, Claude is give me another question. I keep coming back. I keep coming back to this. I keep coming back to horrific. Horrify. Yeah. Because it's a play on terrific and horrify. I love it. That wordplay is what's really getting me. It's what's just, it's tickling me. Braid is a lovely name and a lovely, an incredible game, as I've mentioned every single day. Jonathan Blow, you know, hats off to you for making such a cultural icon, in my opinion. But the more I say horrific, the more I like it, and the more it sticks better in my brain than braid. Horrific. Oh, I'm feeling it, I'm feeling it, I'm feeling it. I'm feeling horrific. I am feeling horrific. Because if we do call it horrific, then I can go through and change all these names that was like fun. Like Hard Streamer. We call it the Hard Screamer. Oh. Would that just annoy people though when they're trying to use it? Actually, who cares are using it? This is a single binary. It's not an API, it's not a library. Maybe it should be a library. Maybe it should be a library as well. Does anyone need a fast hard parser? Maybe. Maybe. It's very specific. I'm not sure people would need that. I'm not sure people would actually find use of it. Do you need to parse a massive half file in Go? It's like, yeah, you're Jason. The end. But if you need it to be really, really fast, I don't think people would go looking for a super fast har parser. Then again, I don't think that a lot of people would go looking for a super fast har explorer. But we need one. And that's what I'm building. Compatible on everyone's system. Everyone can use it. Because it's a terminal UI. I am planning on building some native Mac applications at some point, but not for some time. I've got another project I'm starting soon as well. I'll be weaving in between Princess Beef. It's a Princess Beef product, but it's not in the same space at all. It's actually not in the business space at all. I'm not going to talk about it yet because it's a surprise. But it's coming. Just like horrific is coming. I'm gonna mix horrific and braid. I'm gonna change the name to horrific. I'm gonna do it. I love it. I love it so much. I love it better than braid. And I didn't come up with this name until I started working on it. I came up with braid first. I came up with the name first. No, I didn't. I came up with the idea first, then I came up with the name. I came up with the name ages ago. But now I'm actually building it, and I like horrific better. What do you prefer? Braid or horrific? I don't know. No, I do know. No, I do know. I do know. Yes. I do know. now we've dropped to 9.3 seconds. What happened there? Speed and accuracy. Well, it's telling us after it's run, if it's run all the, it's cleaned all the code, it's fixed everything up, it's run all the benchmarks, and we have seen a 1.47 times speed up. I don't know why we've lost that speed. We were running pretty good a minute ago at 6 seconds. And now it's not. Now that could be just the benchmarks or the way the benchmarks have been designed. We're going to go give it another go here. I'm going to run it and see if it works. But it has, we've lost a couple of seconds there. According to the benchmarks anyway. Somebody's trying to reset all my passwords. Don't you love that when someone tries to do that over and over and over again? Yeah, well, it's not someone, is it? It's a bot. Somewhere in... oh, it's probably China. Probably China. Warning. Data race. We have a race condition. We have race conditions. Race conditions. Looks like it's time for some more mutex. Mutexi. Mutexes? Mutexes. Another mutex. And we have many mutexi? Mutexi? What is the plural? It has to be plural. Mutexes. Has to be. You don't really talk about mutexes though in that context. A mutex is a... it is that lock. It is a lock. Or a switch. Depends on how you want to... depends on how you learned about locking. Or switching. Or however it's implemented in your language of choice. Nevertheless, understanding how mutexes work and the value is critical, and you really can't build very much asynchronous code that's performant without them. You can. That's not true. That's not true. You can, but when you start bringing in certain data structures that, like maps, for example, you can't read and write to the same index or from the same index, you know, at the same time, two threads. So you need to lock, and you know, that's where you start getting in trouble. Or use a synchronous map, which will do it for you. Locking for free locking. Well, it's not free. It's nothing's ever free. Always comes with a performance hit, but you basically you write that hit yourself, or you pre-package it. Decoder V2 and Marshall. Let's see how much of all of our work is being slowly stripped away as we refine the code into actual working code. And we're going to end up right where we started off. So like, oh, well, we removed this and did this, and now this is right, and this is right, and this is right. And oh, sorry, you've actually increased. It's slower now. Yeah, when we hit that 6 seconds, I mean, we can do it again. Let's do it again right now. Let's do it again right now. We'll bring up terminal 2 and code. I'll do it right now. There it is. 6.4. Beautiful. Oh, hang on. Beautiful. Back to Claude. Now he's fixing generated nonsense. Oh, there were the emojis. I really hate the emojis. I really hate the emojis and all the AI stuff. The rocket ship. Oh, God, the rocket ship and the green tick. Or the clipboard. Get rid of damn emojis from models for doing lists. Anything. No emoji. Like, it's just it. I don't know if it's a generational thing. I'm what's known as a Xennial. A micro generation. From a micro generation that crosses two worlds, two generations of a bridge. So I understand the analog world and I understand the digital world, with experience in both. Partly why I love interfaces so much. But I'm missing the emoji thing. Emojis bloody everywhere. Everywhere on everything. Drives me nuts. Can't read it. It's like adding random symbols into stuff. I'm not sure if it's my age. I don't know. I'm not that old. I'm really not. I'm not sure how old I look or how old do you think I am. You're probably wrong. But just put it this way, if I say I'm a Xennial, it puts me into a very narrow band of ages, so you can figure the rest out for yourself. Alright, Claude, you're telling us that we're approved for... You ain't telling me nothing about approval, my friend. You are not approving a damn thing. We are not... We don't trust you. We don't trust you yet. Okay. You see these benchmarks. Provides 1.56 faster indexing whilst maintaining 100% accuracy for offset tracking. All the tests passed. Entry loading works perfectly, and the code is clean and production ready. Okay. So V1, the standard library, we can index. Look at that. That is impressive. That there is something that makes me very happy. It's the 35,000 allocations, and just using the standard library without the experimental replacement, and then using the experimental replacement was 11,000 allocations down. Look at that. Look at that. That is amazing. $24,000 allocations. 24,000 allocations. Or more than that, but look at that. It's not what with 8 point. I don't know. So we've added. We were at 6, 7, 8. Is that because of the extra work we're doing? Let's see how it works. We use V1's JSON decoder for token level passing. Excuse me. So it's basically the way it's saying that to get the best out of this combination, because of our custom scanning that we need that doesn't gel with some of the limitations of the V1 and V2. because we got to make this work. We got to engineer a solution, and the solution that Claude is saying is what it's recommending. We use that was not recommending. It's how it's built it. We use JSON decoder for token level parsing, which gives us what we need, and we intercept decode calls to capture the raw JSON bytes, and we use V2's new unmarshal for fast struct decoding. So we're using basically, this is really what I wanted to get out of the machine anyway, was using the unmarshalling. If you think back to the beginning of the stream, I'm not sure if anyone's watching or everyone's even knows what on earth I'm talking about, but at the beginning of the stream today, I did say I want to get the use out of that unmarshalling capability, and that's basically what we've ended up with. You know, pushing and shoving and going backwards and forwards and trying to make this work. We got good coverage. That's exactly what it should be. It was 75, so 74.9 is fair enough. Entry loading, no compiler warnings, clean build for both versions. All these critical issues and code quality problems were cleaned up. And it's saying we can just go and build it. You know, I'm actually going to run it again. Okay, so we got pre-existing conditions. Okay, so that's a race condition that already exists in the main branch we need to fix. Yeah, you're not approved for anything. All these green ticks everywhere. It's just so unnecessary. Doesn't add any value. Code review passed. We're memory efficient. This is great. Like it runs faster, and we got much fewer allocations. That reduces significant pressure on the garbage collector. Again, not that it matters, but we're just thinking about, you know, building the best that we can build, being clean, being the most performant, and not taxing the machine, you know, because of our designs. And having this here with this improved decoding and unmarshalling, it's handling strings way better. It's a much better design under the covers, that is, and that's what we're using. And it's architecturally clean, yeah. Build tag separation, yeah. Okay, benefits 5 seconds faster, 67% reduction allocations, 100%. It's not merged and ready to ship, you nutcase. Not. Oops, what have I done here? I've pressed the wrong key. Let's let's go over here and run it. Let's build it. Build it. One, 2, 3, 4, 5, 6, 7, 8, 9. So in 9.9 seconds, nearly 10 seconds, it is faster. But we've lost 4 seconds in this somehow, and I'm going to ask Claude why. It is better. Memory use seems to be better. Well, I don't know that. I haven't profiled it yet, but anyway, yeah, but it's nowhere near as happy now. That was like a take me up to the top of the clouds and then kind of drop me back off down on a hill. Hey Claude, we were running at 6.3 seconds or 6.4 seconds for a 5 gig file, and now we're back up to 10 seconds. What happened? Why have we lost so much speed? We were running so much faster with the indexing. What happened? Oh, I better tell it to not start editing. I don't want you to edit anything or make any changes. I just want to know where we've lost those 4 seconds. What changed between where we were and where we are now? To lose those seconds, what did you add? What did you change? Let's see. What you got? What you got? What have you got? Because yeah, it's better, but it's not much better. It's not great. But it didn't work when we had 6 seconds because we hadn't actually done the hard work that we needed to do. I think that's what the problem is here. Is the 6 second was a red herring. Because yeah, we did an index, but we didn't actually know where any of the data was because we couldn't figure out the offsets because of the API that we built and we were working with. So we tried wrapping it and tracking it that way, and it didn't work very well. So I think that was a problem. That's why I got all excited. But only half the work had been done, so it's a red herring. If you don't know what a red herring means, it's misleading, like it's a false positive. Because we weren't not looking at the code in depth. We're just running off what the agent is telling us, and we're trying to execute that. There's that. There is always that, and it's part of the black box element of AI. So let's see what Claude is saying. It's saying what changed. When I switched from the custom JSON text decoder approach to the hybrid V1 V2 decoder, I introduced double parsing. The first pass is decode raw, validates and passes the JSON with V1's decoder. The second pass passes the same bytes again with V2. The 3-4 second loss comes from passing every entry twice instead of once. The change was made because the original V2 used JSON text decoder read value, which just reads raw bytes without passing. But the counting reader count tracked buffered I/O, not actual pass position, causing offset mismatches. Yes, that's why the readout was breaking. To fix the offset accuracy, I switched to V1's JSON decoder, which has accurate input offset. That's what we were doing originally. But V1's decoder doesn't have a get raw bytes without passing operation. The only way to capture raw JSON is with decode raw message, which passes it. Okay. The only way to capture the raw JSON. I'm not sure that is the right way. Let's just dive into this. The only way to capture the raw JSON. So let's ask this. So Claude, you said this. I want to dive into this a little bit. Quote, the only way to capture raw JSON. So I'm understanding we don't get the raw bytes without passing because that doesn't exist in V1, does exist in V2. Again, this is another complication of the mix and the match and trying to deal with this. So my question to you is that you said that the only way to capture raw JSON is with decode. Is there another way for us to stream in these bytes without using decode? So we can get offsets, so we can achieve it without having to decode it. Like the double decode, I think might be a mistake, but I don't know what the other options are. I'm pretty sure we could use just another form of reader if we know where to read from and how much to read. Let's see what Claude says. What do you think he's going to say? Go away. Old man, go away. We don't care what you've got to say. Not today. Coffee's good. Wow, I say good. It's okay. Not a great roaster this time. Use a company called bottomless.com, and there's a scale next to my coffee machine with my coffee beans on it, and it monitors how much I'm using, and when I start to run out it orders me some new stuff. But it's picked, like I forgot to update my list a long time ago. It's just running on autopilot right now. It's just picking random crap out of the air, and I got some random crap this time and it was yuck. All right, look what it says. It says, you're absolutely right. You know what that means? We are absolutely right. I overcomplicated this. Let me explain what we should do. The real problem is the indexing. Yes. Yes, mate. The indexing phase, every field extraction is double passing. Thank you. We don't want to do that. Pass number 1. But decoder.code now does blah, 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 blah. Pass again. The original fast code was no passing. Just read the value, just the bytes. And then we pass the metadata from the bytes. That's what I want to do. That's what we should be doing. There's no reason for us to always decode twice. Silly Claude. Silly Claude. We capture the bytes on the scan and we decode on demand. We only need to decode it once because it was just decoding the metadata. Or we should be anyway. That's the theory. Let's see what it comes up with. We use a capturing reader during indexing. The capturing reader reads the bytes, captures we need it, yeah, and then during pass metadata entry, there we go. And then, okay, or even simpler. Since we already know the offset and the length, that's all we need, buddy boy. That's all we need to be able to use a really, really efficient passing mechanism. There, that's what I'm looking for. Hallelujah. File seeking. Thank you. That's what we need, not bloody decode. Frigging decode. You stupid ass. That's not how it works. That's not how you code, mate. Well, it is how you code. It's how you code badly. Let's seek the file. We know where it starts. We know how long it is. That's the whole fundamental part of this design, to create the index. 1 pass, V2, and that's it. There we go. Yes, Claude, this is the design I would like you to implement. Actually, the simpler design is what I would like. Using file.seek, because we have the offset and we know how much to read. That's all we need to be able to do the most efficient binary lookup, and then we can, pass on demand. So please implement using the simplest method to get back to our 6-7 index string parsing, please. Now we're cooking. Now we're going to get the best of both worlds, and we're going to be able to go and seek at that position rather than relying on JSON decode and all that magic that comes with it and all the bump that comes in it. And we're losing 4 seconds. That's a lifetime. That's a lifetime that we've lost there, and it made me very sad. Now it's it's little boy saying, "You've been upgraded. You've been upgraded." Really? And then you still turn right when you get on the plane, and then you walk past business, or first. It depends on whichever plane you're getting on. But you walk past the posh section. All the rich and lucky people are sitting, and then you move in to the premium section, where the not so lucky and not so rich people are, or people that refuse to pay money for premium travel. And then you get into regular class. You say, but I thought I could upgrade here. And no, you got a bottle of water. That was your upgrade. Right. What is you saying here? You're absolutely right to yeah. Right. You're absolutely right. Yes. You're absolutely right. The speed loss problem. Yes. We use the decoder decode. No, the slow is what we're doing right now, which is the 2 double pass. The double decode is stupid. It's the wrong design, man. What are you crazy? You're crazy, my friend. And then we're gonna fix it. We're gonna fix it with a file seek. Keep the fast v2 indexing, but fix the... Oh no, we're going back again. We're not going back again, are we? Oh no, you're saying that you figured out how to use... I was wondering why you couldn't figure this out. Too much trust in the AI. Summing those lengths, yes. Sorry, I'm thinking out loud. I'm thinking in the inside instead of saying what I should be thinking here. Once the LLM has now gone through this and it's, you know, recalculamified the predictive text that it's generating here, it is actually saying that there shouldn't be passing, there should be bytes. That's the whole point. We don't need to pass it, we just need to know where the bytes are. No. What do you mean raw entry read value? Hang on a minute. All right. Should I implement this fix to get back to 6.7 indexing with accurate fixes? You were struggling with being able to track offsets accurately before. What's different now? Thinking. I wish. Not thinking. Absolutely not thinking. Running a bunch of marbles through a Goldberg machine more likely is a more accurate description of what's actually happening at the moment. But it is a fun. Oh, it's like playing a fruit machine, all right. One-arm band. Whatever you call them these days. Oh, what do you call them in Vegas? Slots. Oh dear, what we got here? Excellent question. Here's what changed. Where we lost speed. Just reads the bytes, no passing. One pass with a marshal. Yes, that's the right way it should be. Current data slow. Pass 1, 2, 3, 4, 5, 6. Yes, this is wrong. Yes, the root cause. I switched from the fast read value approach, which doesn't pass just read bytes, to token by token decode, which is where we're seeing that massive slowdown. It's like we're losing all of the value of the whole point of this exercise with this nonsense approach you did here. Not what I wanted, but you did it anyway. You're right that we already have the offset and length with the skip being written. We already have it. The real question is, were the original V2 offsets close enough for skip being read to fix? The original V2 offsets were off because tracker.pos is tracked with buffered IO, but if we calculate offsets by summing, what's that what you should have been doing anyway? It'd be much closer, only off by the white space between the entries. The white space doesn't matter, because you can trim it. The question is, should we go back to that read view at value approach? Let's commit this so we can just make sure we're still building. I just want to still make sure we're building. Yeah, it's still building. You know what I want to do? I'm going to commit this because we do actually have working code right now, and it is 3 seconds faster, although it's not the right design. Let's not give ourselves a big old headache because we're in a branch and it doesn't really matter. Let me do that. I'm going to come over and to tower, and I'm actually going to say, let's all jam all this in and say proto. Actually, I'll talk it just easier. Prototyping experimental v2 JSON decoder implementation to dramatically improve indexing time. That's too long. Prototyping. I'll copy that out, I'll paste that in there, and I'll just say for the actual first part of the message, which is the part that matters most. Prototyping v2 JSON API. All right, let's they save all that. Yeah, there's a whole bunch of stuff in there. It's not a huge amount of code. It really isn't. It really isn't a lot of code in there. That's all we've written so far. That's pretty pathetic. All this backwards and forwards, man. It might have been faster just to read it and write it myself. Hey, then again, there'll be a load of learning, and yeah, I'd have to learn on the job, and I don't want to do that right now. I just want to get productive. It's not a huge amount of code that we're talking about here. This is pretty rubbish. But I want to save it because I just don't want to come back to this. So I want to switch back to my terminal. All right. Yes, go back to the fast revalue approach with the cumulative length tracking. I want to get back to those 6 seconds. I'm not going to give that up. The approach that you've added with the multiple decodes is not satisfactory. It's too slow. Let me, whilst that's rolling, I'm just going to go and look over here. I've got another computer over here. I need to go and check some things and make sure that there's no one screaming at me saying, you missed the thing and the thing's not working now. Well, I can't see any things that needs my attention. Can't see anything that need my attention. So, with that, whilst Claude is cracking on with fixing these few lines of code here, I'll be right back. What are you doing? What are you doing? You're deleting XX hash. Why? Why? What are you doing? What are you doing? Let me implement that. What are you doing? Okay, well, I'm glad. This is why I'm glad that we committed that code. Because of this. Like, what are you doing? I'm just gonna let it go. I don't know what it's doing, but I'm letting it go. Either we don't need the hashing anymore, or I don't know. The context is poisoned, and we're building something else. We're building an FTP client now. But why? Oh, because I thought you wanted to send files. No, Claude. No, I don't want to send files. No, I don't want to do that. I do want you to freaking do what I told you to do, you freak face. Go fast. Oh, we've got ticks now. We've moved away from emojis and we're on to just tick ASCII code. Oh no, we got the emojis back. Panic at the disco. Actually, I went into a shop the other day. I was where was it? Guitar Center. It was Guitar Center. I went to the Guitar Center to buy a little sound card and a MIDI controller for my daughter who wants to play music and record a voice. So I did that, and I said to the guy, "Hey, do you have any MIDI controllers? I don't want to order on Amazon." In fact, I did actually order it. I ordered it from a great company called Sweetwater. I love Sweetwater. If you haven't, I love music, by the way. I have a big lot of music equipment. Check out Sweetwater, great place. But FedEx are sometimes they're terrible and they hire, I don't know, homeless people to deliver packages, I think, who don't read addresses and don't know how to deliver packages. You see them driving up in like a Hertz rental van, and they drop off. Well, I say drop off. They kick a package at your house. Great service, thank you, FedEx. With that, high quality trained drivers. UPS, you never see that crap with UPS. They're always very, very professional. Got the brown uniform on. UPS. I got a friend who's a UPS driver, and never a problem with UPS. Go UPS. FedEx. It's like the Walmart of couriers. Prove me wrong. I didn't realize I've been muted. I've been muted this whole time. Thank you for telling me that. I really appreciate it. I thought I was talking. I swear I was. I've been standing here talking to myself. Well, I've not been talking to myself. I've been talking to you or whoever's listening, watching. I'm not paying attention. Who's watching? Thank you for watching. Really appreciate it. Thank you very much. Yeah, it's very nice compliment to be titled young. I have been doing this, for a good 30 years now. Started in school, left school when I was 16, went into tech support and started building businesses and hacking code. Never stopped. Right now we're in the middle of a refact. We're trying to get squeeze seconds out of a piece of passing code that we've been working on for an engine for a brand new tool that we're building live during this hackathon. This is day 3. And we're trying to get it to go back to, we had a whole bunch of performance gains, and Claude screwed it all up. I didn't screw it all up, it just made some stupid decisions against the principles of what we're trying to do, and just didn't think, and I didn't look hard enough. So now we're kind of going backwards and forwards. We'll get there, and it's not working now. That's actually the same, that reader test there. That actually might be from the old test, but that was one of the problems we were seeing before, earlier. He's been running for 16 minutes now. 16 minutes. The offset is still slightly off because I'm not counting the white space. White space will mess you up. It will mess you up if you're not careful. So we've got to add in a colon and a left bracket to make sure it can handle that landing the bytes before it. Or just trim it. Just trim it, mate. Or maybe we can't do it from that. We can't do it yet because we're just literally reading bytes from an offset. So it's struggling with that. It's struggling, failing to read entry. What it's doing here is trying to figure out how to get the exact bit in which to cut. And when you got white space and you got characters and JSON, it can be a bit messy. I think this is going to go backwards and forwards here for a minute. Skip all the white space and structural characters. Yes, the tests are failing. These could be old tests. It could be tests it's just built. I haven't been tracking it. Come on. The issue is now unexpected end of file, because when skip leading reader, it skips the bytes, and those skip bytes are counted against the limit, but the decoder doesn't get them. That's because we are delimiting it incorrectly, Claude. Entry. Why are you adding 10 in there? What's that for? Why have you put a magic number in there, Claude? Entry len plus 10. Perfect. All the tests pass. That doesn't fill me with confidence. How do I enjoy Twitch so far? So far, I'm having a blast with this, to answer your question. I'm just going to call you Taras, if that's okay. Keep it short. I'm loving it. I'm having a great time. To be honest, the most rewarding thing so far, to be honest, is the real-time rubber ducking that I'm doing. Like now, what I'm doing is I'm literally letting my internal stream of thought come out of my mouth. Obviously with some filters on there, and I'm trying not to swear. I swear a lot. So that's very hard for me. But oh look, we're back to 5.6 seconds. Yes, we're good. I'm gonna let that run for a minute, and I'm really enjoying the fact that when I'm thinking through this stuff. So what you're watching me now work with Claude Code. This is the new way. This is how things have evolved over the last 6 to 8 months. this is now a power tool. This is a real power tool for engineers, and I strongly recommend it. It cuts off so much time and thinking, to the point where I can actually sit here and work on highly complicated code and still be able to talk to you and be able to give you a running commentary. But back to answer your question, the thing that I'm enjoying the most, it's being able to think through these ideas verbally out loud. Now that's a technique that if you work in an office, you do it all the time, particularly if you talk to your colleagues. But some people are remote. I'm remote, and I'm only in the office for set times, every month or two, and it's hard to really think through some of these things mentally. Like, it sounds like a good idea in your head, and you start building it. And a lot of the time, I found that when I start building things, I have to back out, because when I start building them, I realize that I didn't think it through properly. And this is what I've realized here: is I'm thinking these things through with a lot more detail. Because I'm reading out what the LLM is presenting, so I'm being more thorough with the reading. Claude Code. Yes. Am I sponsored by them? No, not at all. I have no sponsorship from Anthropic whatsoever. None. I just use this tool. I use this tool. With it, I use Claude Code Max. I use their Max subscription because it genuinely works. And I sold the exact same tool internally. I work for a company called Cisco, by the way. You didn't know that. I'm a distinguished engineer there. And I sold this internally, and it kick-started an AI thing that we're trying to get people using AI, is because it's something we need to do. But we've also got Codex, which we will be using on the stream at some point when we get to a code review. We're not quite there yet. We're not ready for that. Hang on. I'm just going to see what Claude has given me. Oh, it's running a test. But I use this tool, and I highly recommend it. I've been building now for it with about 6 months daily. And I'll show you, like, if we flip over to the other terminal, show you over here, this is the application we were running. Our last run took 8.7 seconds, which is not good enough. Let's quit. And if I do show my use of the LLM CC usage, this is a tool called Claude Code Usage. It's you can see here, this is what I've done for the last month. And if I was paying via the API, yesterday we used $100 worth of tokens. Today we're at 26, but it's a total of 1,500. If I was paying for it by the tokens, which I'm not. I'm using the Max subscription. So there's another comment. I want to build a tool based on LLMs that would be custom tailored for me. So when you say you want to build a tool based on LLMs that's custom tailored for you, what exactly do you mean? A tool to do what? What does a tool do? So you can build anything that's tailored for you. But what is it that you want to build? That's a tool based on LLMs. So it uses LLMs, or is built on top of LLMs, or it is like an API client, and you use like OpenAI or ChatGPT or whatever, any kind of Gemini or whatever your flavor is. Is that what you're looking to do? What do you want? What is your tool supposed to do? All right, so over on the code, we have our performance code reviewer is another agent that I put in there that is checking up on the quality, and it God, spit it out, quobix. Claude is just building some tests to validate stuff. The answer to my question is from Taras. Using an LLM API to perform some queries, which I do by hand. I have a custom workflow that I do with LLMs I want to automate. Okay, that should be really easy. What LLM do you use? Do you use like an agent framework? Do you use Copilot? Do you use an IDE? A cursor or something? What's your flavor of choice? Cleaning up the test files and running the final code review. back to 6.5 seconds and entry loading works. Let me verify. V1 still works. I usually run this. So the answer on the chat is Taras says I usually run 3 in parallel: Perplexity, Gemini, and ChatGPT. Claude wasn't my cup of tea. I do not code with LLMs, just research. Okay. Yes, I've not actually used Claude for anything other than coding. When I do research, I use ChatGPT, and I've used Codex as well. But for coding, specifically for programming, Claude Code is unbeatable. I will put money on it. Right now, anyway. Right now. That could all change tomorrow. That could all change tomorrow. All of it. You know, this race is moving constantly. But today, and for some time, Anthropic, in my opinion, hold the cup on quality when it comes to software generation. There's a load of other like Rue code out there, and I mean, they're changing all day. There's loads of these great startups that are building these interesting products based on top of LLMs for coding. But in my opinion, like I did a bake-off. I had a Gemini and I had Claude here. I ran Gemini, I ran Claude, and Gemini was rubbish. It was rubbish with a capital R. Rubbish. It didn't do anything that I asked it to do. It built a big pile of nonsense, like working slop. When I say working, it compiled. It didn't do anything else. So, and then I asked Claude, this is when I was kind of deciding which way do I want to go. Do I want to invest in Google, or do I want to look at the next set of contenders? And Google was like, no, that would be a career mistake. But then I tried out Claude Code. Same thing, same prompt, same everything, and it delivered exactly what I asked it for, which is actually a precursor to what we're working on today. It didn't do anything at all. It was just a sample, but it did do kind of what I was asking it to do, and the code wasn't bad. And from that point forward, I kept experimenting and realized that it was actually much, much, much better. So for coding, you can't get better than this. You cannot get better than this, in my opinion. But for everything else, I don't know. I've not tried it. I've not really tried it in that aspect. I've got the Claude desktop app. I use that occasionally, but I still drop to ChatGPT, to be honest, for most of my research. I just find it very effective for that. But Codex, it's slower. It's as good as Claude Code, but it is slower, in my opinion, which is part of the experience. All right, so let's see what we've got over here with our final performance results. The JSON v2 integration complete. We are production ready. Yeah, BS. Don't believe it. Don't believe it for a second. Do not believe the hype. It is not ready. Not ready at all. But we have a 5 gigabyte HAR file. This is 2 times faster. Perfect. I'll take it. I'll take it. Take my money. With a 500 megabyte HAR file. Now this is more akin to what we will actually see in production when we're deploying this. 1.36 seconds was before. How is Cisco? Cisco is very interesting. It's a very different experience for me. When I say very different experience, that's not true. I've been in very large companies for some time, for over 10 years now, nearly 15 years. And before I worked at Cisco, I was at a company called VMware, which was a pioneer in virtualization. If you don't know what virtualization is, it's dinosaur technology, but it's still relevant, very relevant. Not as much, but it's still relevant. Go look it up if you're interested. I worked there for 10 years, and then I joined Splunk. And if you don't know what Splunk is it's an amazing product for analytics. It's just this, in my opinion, best-in-class analysis engines. unstructured data from every source you can imagine. Windows applications, log files, daemons, applications, you name it. You can throw it into Splunk. And, oh, you've used VMware and Splunk. All right, I'm going to shut up then. So you already know what I'm talking about. So, yeah, I'm a distinguished engineer at Splunk, and I work in security. Which means that, well, I say Splunk is now Cisco because we're owned by Cisco. So Splunk as a company doesn't exist anymore. It's gone. It's Cisco. It's just Splunk is a business entity, or a BE. I think that's what it means. I hope it's what it means. Anyway, difference is when I was at Splunk, there was about 6,000 of us. Now I'm in Cisco, there's like 10,000 of us, or 90,000 of us, or one of them, some ridiculous number. So it's like a little bit like being, a very big shark in a very small pond to go into being, just a regular sized shark in an ocean. So it's very different in that sense, but it's also full of opportunity and excitement. Plus the company's doing some exciting things at the moment. Stock is up, growth is there. We're doing some great stuff with AI. It's actually a pretty exciting place to be. I didn't think I'd ever say that, but I am saying that because it is, and things are pretty exciting. For now, anyway. We'll see we'll see what the future holds. But it's good now. Where are we? Yeah. We are on the achievements. We have 2 times faster indexing. And we are actually working. Well, it says it's all working. The tests all passed. All right. I'm going to believe you on this, Claude, because we're going to run it, and you've not let me down yet. When we've gotten to this point, you've not let me down yet. So let's keep going. Code quality. Magic number. There it is. I was wondering why you were doing with that. Yes. Oh, you documented it. So we are going to keep the magic number. Oh dear. I'll have to look into that. Magic numbers are never a good idea. But in this case, it might... I don't know. No, it actually can't be. Ooh. So look. This is my big book of mistakes. I believe Cisco was a darling of a second way of technology innovation in the US. Well, I mean, Cisco really kind of broke into the scene on the dot-com boom. If you take a look at the stock for Cisco, and you see like 1998, 1999, it's like this massive spike, huge bubble, and that all popped. And I'm not going to go into what happened there. The story is as old as time, but as you know, Cisco kind of lost its momentum after that, and it's taken it nearly 20 years to regain it. More than 20 years. More than 25 years. 25, nearly a generation, over a generation. Or is it 25 years a generation? I don't know. Was it 20 years? Anyway, almost a generation to pick up, to get back to that point. Yeah, I mean, Cisco it's a big networking company that has been moving into software and security, and kind of trying to combine the idea of, we got the networking covered, now we've got the security side covered. We're kind of best in class in that entire world, which is true. There's no other companies out there that do security and also specialize in networking. I don't think that exists. I mean, you've got networking companies that do a bit of security, but because what we do, and there's already a security business unit at Splunk, but what we do specifically with Splunk security really reinforces that. The question is, which Cisco products do you use or recommend? I don't know. I don't know. I don't have an answer for you. Everything I would recommend would be Splunk. I can't tell you what Cisco products to use, and it all depends on use case, because I think they make phones and switches and all kinds of things I don't even know about, things I've never even heard of. As I say, I specialize in software, and in particular software interfaces, so I can talk to you about that all day long. But Cisco products, wrong man. I am the wrong man for you. I do not know. Let's get on with this, because I want to run this code, and I want to see this 6.5. I want to see it. and then it's 12:13 here, and I've been streaming for 3.5 hours. Ooh, look at it. Let's see. Cause I'm gonna take a break here. We'll get coffee in a minute. You run Ubiquiti Unify. Oh yeah, Ubiquiti is great. A lot of people use Ubiquiti. I've got family members that use Ubiquiti. I run a Sophos firewall, and I run networking gear by a company called Access Networks. Yes, I am on the East Coast. I am in Virginia. in Virginia. I know it's still pretty early on the West Coast, but the reason why I'm doing it so early is A, because I'm up earlier, but B is we've also got a distributed team, because what I'm doing right now is actually part of an internal hackathon. We have a week and a half to build something valuable, and everyone in security is right now hacking code on something valuable, their own ideas, their own inventions, their own creations. I'm just choosing it to do it on the public internet, mainly because A, it's something different, B, it's a lot of fun, and C, I want to do more of this, so I'm using it also for practice as well. So I'm hitting lots of birds with one stone at the moment. But what I'm building here, this is actually part of a hackathon. It's a real hackathon. Yeah, hackathons are great fun, particularly if you do it properly. Like if you're given the time to do it, and you're not like, here's a hackathon, you've got 12 minutes, go. It's like, who cares? I don't care. I don't have 12 minutes. I don't want to spend 12 minutes trying this out. And obviously it's more like a day, or 24 hours. But I don't know. I don't want to stay up all night. I can't stay up all night. I'm an old man. I'm in my mid-40s. I cannot stay up all night long. I got to be in bed by 10. So they're not for me, right? But now we've actually got a week and a half to do this. And we're on day 3. And I'm having lots of fun. Lots of fun. Lots and lots and lots of fun. Just standing here talking about this as I'm going along and being able to talk to people like you. Say hello. Yeah, this is... I've actually had this tool idea in my head. The question here is I usually start building tools for hackathons. This is a hackathon. I'm doing a hackathon right now. This is hackathon. I'm hackathon. This is hackathon. You are at a hackathon at this very moment. This is hacking, lots of it. Look, we're hacking code at a hackathon. I need to go back. No, where are we? Where are we? We're gonna build braid. That's right. We're gonna build braid. No, that's 5 megabyte. That's not right. No, that's just running. We need to build it. Build braid. Now run it. 5 gig. Let's see. What was the name of the networking equipment company I just mentioned? They're called Access Networks. They actually, I'm not sure you can even buy it. It's stuff that usually go to dealers. It's specialist equipment that's used for home, like it brings like enterprise grade networking into the home. So it's stuff you normally see in a data center, but it's in my house, and I need that in my house because my whole house is wired up with fiber optics, and I've got Cat 6 running to every single room. There's 4 floors in it. I've got a data center down in my basement, so I need an entire set of switches to be able to manage all of the video, the audio, and the networking, and then all of the control that runs around. Control being every television, every sound output, every speaker in the ceiling has a control wire for being able to turn it on and off, and that's run over Ethernet. I use a system called Savant is the main control, and I've got all kinds of other pieces coming off of it. Access Networks specialize in super high bandwidth audio, video, and home networking. It's basically like it's to bring like 10 gig networking into the house for real, not kind of like made up, because they'll run it over fiber. It's Access Networks. You should go and look at them if you're interested. And look at Savant. A great, amazing product. I've been using it for about 5 years. Whole house is powered by Savant. Whole house. All right, we built it. Now we're gonna test it. 6 seconds. 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000, 6 1,000. Darn. Yes. 6 seconds. Let's do it. We've got to scroll, and the real test is if we hit enter and it actually loads. Ah! Damn it. Claude, you lied to me, man. You lied to me. You said it worked. And I do see the 6 seconds return, so we're all good there. But it doesn't work, Claude. It just doesn't work, Claude. It doesn't work. I see this when I hit return on anything. How disappointing. I was all pumped. I believed it. I believed the hype. I believed you, Claude. Ready to merge. Liar. Liar. 2x speed, 100% accuracy. Liar. Oh, look. You're absolutely right. I apologize. Of course we're right. You're absolutely right. Yeah, I know. Well, I didn't know, did I? Well, I knew it. Yeah. This is the part of the day when I start getting annoyed. And 4 hours in, and we're now going with the AI, and we're nudging it left, and it's not right. And then we nudge it again, and it's not right. Oh, hang on, it says fixed it. Come on, Claude. Don't let me down now, buddy. Don't let me down now. Production V2 binary ready. What was broken? Let's see. Ugh. Fixed. Entry loading now works. The 10-byte padding wasn't enough. When skip leading reader scanned forward to find the entry start, right curly bracket, it consumed bytes from the limit reader, leaving insufficient bytes for the actual entry passing. This seems like it's really fragile code. Like it's gonna just fail. It feels fragile. With that magic number in there, it's making me extraordinarily nervous. I haven't looked at the code yet. I still haven't looked at it because it doesn't work. It doesn't work yet. So I'm not looking at the code because I don't want to start fudging around with that because the design could be wrong to begin with. Let's get it working and then we'll refine it. But that magic number is making me really nervous. Now, I've seen the 6.5, the 784 megabytes a second. That's what we want. That's what we want. 87% less memory. Oh, that's very exciting. 48k allocations. This is can't be right. 615 megabytes of memory. That is wrong. Okay, I'm not going to listen to these numbers. This is just made up LLM crap. Taras says, I made a to-do wheel, a physical circle with 32 accidental power of 2 places to-do items. Wow, that's a lot. And I filled it in a day. And I realized you need the help of AI to go through most of them. A physical circle. So it's like a wheel? What? How do you mean a physical circle? A to-do wheel? It is a wheel. How do you should tell me about, I don't know how would you use that? How would you navigate it? I've seen wheels before. Yeah. I don't know how you send me a photo on this. You just spin it. Oh, okay. Sounds fun. It sounds fun. I think I can imagine it. Oh, like a Wheel of Fortune. Oh, it's like a Oh, I see. I was thinking of it was side on, like like a, I don't know, like a dial or something. But no, you're talking about it's like a face, like a the face is like the edge of the wheel, but it's facing forward, like a number scroller. Yeah, I know what you mean now. I know what you mean. I do. All right. Well, it's saying it works now. It says it's fixed it. Let's go back to the other terminal and see if it actually did it. Let's build it. It says it's already built. 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. Yep. Yes. Now let's pick the moment of truth. Dun 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 dun. I work. Yes. Yes. We have liftoff. We have liftoff. No, we don't. We have a failure. Almost. 1,000, 2 1,000, 3 1,000, 4 1,000, 5 1,000. Well, look, the scanning is working fine. And picking a random one seems to work fine. Body empty, tiny. It's not passing it properly. It's not working, is it? It's not working, is it? Or maybe it is. No, it's not working. This experiment is not shaping up to be... Oh, no, it is working. Oh, my God. It's so... This magic number is what's causing the problem. I'm going to take a break. And I'm going to have a think about this for a minute. I'm going to take a break for 5 minutes. We'll come back. What is it? 26. I'll be back at 35 minutes past. I'll take 9 minutes. Take 9 minutes. Yeah, 35 minutes past. There we go. So back. Let me quit this because it's half working. I'll do this back at 5 min. Past the hour. All right, I'll be right back. All right. I need to jump over here for a second. I've got another computer over here, my work computer. I need to do something quickly for a colleague. So I need to move over here. I'll be facing this way for a moment. Okay, sorry about that. I needed to send a Slack. Slickety slack, slickety slack, slackety slap. Okay, now, a problem that we had, if I remember correctly, which wasn't very long ago, your 6-second load, which is perfect, that's our indexing, but we have some kind of mess. Mess. Because if I go here, it works. Let me get all of our stuff. Go down here. Oh, it works. Got all of our stuff. Go down here. It doesn't work. So let's copy that, and we'll paste that in. I've made a copy in the other agent. I'm going to hang on. I'll make a sip of coffee is what I want to do. Excuse me, didn't mean to swallow so close to the mic. Still getting used to. I should be drinking liquid this close to this microphone, but it sounds probably horrible. That doesn't work, right? So we're like, we'll try again. We'll put it up again. I need to type something over here. Actually, no, I can just type it here. I can type it here. Okay. Good. La. Good. See, let's find one of the broken ones. We know which one to look at. That one's fine. This one. BYDAL. Yeah, BYDAL. That one messed up. Paste that in there. Let's come back out, try again. Gotta keep on chit-chatting. Chitty chit-chat over Slack. That one works. COQ6. Yeah, CO6 doesn't like that one either. COQ. Is it O? Or is it 0? COQ. Let's keep going. Let's do some more. So we've got to give it something more to read. Is that whatever it's using is that like, oh, I've got white space. It's like, you what are you doing? What are you doing? Keep reading. If there's white space, keep reading. That one's fine. What's this? FS8L. Doesn't work. FS8L. FS8L. Right, that's enough. We'll get over there and ask Claude to go fix this. Go fix the mess, Claude. So the good news is that it half works. Actually, you know what? I'll put this at the top. Put this at the top of the prompt. The good news is that it half works. The bad news is that it's failing on a number of random items. When I'm going through and selecting random elements, I'm getting just random failures where it can't read because the offsets are wrong. It just can't read. It can't decode what's coming in. So what I'd like you to do is, first of all, here's some examples of them. Now, a number of them did work, and we do have our fast indexing, which I'm happy with, but we do have some logic errors with our offsets that we didn't seem to have before. So these ones failed, see below. And what I'd like you to do is actually render out what's trying to be decoded. For each selection, if it's a failure, instead of just saying the red error, failed to read entry, have a couple of lines under that that's going to render out exactly what was tried to be decoded, so we can see where the offsets are getting mixed up, and just so we know why it's failing, rather than the random error messages that will come out of the decoder are going to be like, couldn't decode string random character. That's not helpful. But actually seeing what was tried to be decoded into a JSON object will be helpful, so we can see where the offsets are all messed up. Can you do that for me? Let's go, Claude. Thought for 4 seconds. Absolutely. Let me add debug output to show exactly what we're doing. We're decoding when it fails. So instead of seeing this just error message, I want to see that the actual section of the basically it's just a big string, right? It's going to where do we start reading from? What's the offset? This is what we're trying to pull out, and this is what we're trying to then decode into JSON. I want to see that and see what's actually off and what we're off by. Because it's probably like you've started decoding halfway through the previous record. You've got half of this, like it starts with just like midway through a property or something, and then it gets the next chunk of the next record. So the whole thing's messed up. So we've got to figure out where it's getting upset, why it's getting upset, and take a look at that. I don't know why it would be, because the delimiting is pretty bloody simple in JSON, my friend. So we've probably got some poisoning gone in here, and it's mixed itself up a little bit. We'll clean it up. We'll clean it up. Because we're not far off now. I think we've got the performance that we want, and we're almost there with, I'm glad we spent this time today doing this, because it's put the engine into a much better place than it would have been versus what we had yesterday. Yesterday was fine. Like what we got, it's totally fine. We could just delete this whole branch and we would be back to a fully operational, ready to go working engine. It's just a little bit slow, and that's not good enough. It's not good enough. It has to be super fast. Otherwise, there's no bloody point doing it. Actually, there's a point doing it. Of course, there's a point doing it, because it's not. What's my version of slow is like, well, it took 15 seconds to load 5 gigs. That's not unreasonable. It's not. But I want it to be faster. It has to be faster. That means when we're loading 500, 600 megs, it's just like, pop! And that is what I'm going for. That is the goal. So when someone pulls down a 2 gig half file, and it loads up in 2 seconds, I'm like, yo, nice. I'd be well happy with that. Well, I can instantly see this massive file. That's the goal. That's the hack. That is a new name. I know that everything's braid. It's got braid on there, but we're going to change the name to horrific. Entry failed. Well, it hasn't main redeclared. Okay, well now it's off doing some craziness. Just have to give it a minute. I'll give it a minute. I'll give it a minute. While we're waiting for Claude to do that, there's a few things that's been popped up on my radar in the last few minutes that I need to look at very briefly. I'll be right back. Right back. Once Claude is done, I'll be back. That wasn't very long, was it, Claude? Oh, we're giving us options. Okay. Perfect. Now I can see the exact problem. The diagnostic output reveals the root cause. We're landing in the middle of base 64 encoded response bodies. I thought so. That's exactly what I said was happening. Those random characters like blah, 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 are base 64 encoded binary content from HTTP responses. The offsets are so far off that we're not even close to the next entry. We're deep inside the previous entry's response body. Why the tracking fails. The cumulative tracking in V2, current pos plus entry length plus 1, assumes 1 byte separation. The problem. Entry length from read value is exact JSON bytes. But between entries, the file has commas, new line, 2 bytes. Dum da dum dum. Or, even more exciting, we have a colon. Sorry. Comma, colon, stupid boy, comma, line break, empty space, 3 bytes with formatting, dum da dum dum da. The smoking gun. So we're adding on these 1 bytes, and this is why it starts out okay at the top, and then it starts getting messed up, and then all the entries down towards the bottom are like error, is because of this. We're assuming the mother of all screw ups, assumption. Never assume, never use those magic numbers. Magic numbers creates assumption. Assumption is the mother of all screw ups. This is our problem. 70,000 entries, 1 to 2 bytes per hour. Look at that. Yikes. We're talking thousands, tens of thousands of bytes of drift. Yeah. Okay, option 1. Go back to V1's accurate offset tracking. Lose the 6-second speed. 100%. I don't like option 1 at all. Option 1 is lose all the speed, but go back to 100% accuracy. Have I tried voice mode? Have I tried voice mode is the question from Taras. When you say voice mode, you mean talking to the LLM? Because that's what I'm doing. I'm not typing that stuff. I'm talking to it. And I'm using a different LLM. For Claude Code, yeah. So for voice mode, I don't know. I'm not using voice mode. What I'm using is another tool called Monologue. It's another LLM. And what it's doing is it's reading the screens that I'm on. So it works for any point your cursor's at, not just for Claude Code. So in Slack or in emails or in Terminal in the editor, and it has context based on what you're typing because it can look at the window. So it comes out relatively okay. Sometimes you've got to edit it, but most of the time I can get about 150 words a minute out of it, which is great because I can only type about 170 at best on a good day. Yeah, I'll give you a link. So the question is, can you give me a link for Monologue? Hang on, I'll show you. Monologue.2. Monologue.2. Effortless voice dictation that speaks your language. So this is what I use. It's for the Mac. So if you're on a PC, then you should use something different. I don't know if it works on Windows. I haven't tried it. Thank you. I appreciate this fancy setup. It took a while to think about how I wanted to do this and the kind of things I wanted to show and how I wanted to do it. But yeah, this is what I use. It's called Monologue, and I use a push to talk, and it works very effectively for me. Very effectively. Took me a while to figure out when to use it, how to use it, how I wanted to use it, but now I use it with everything. I've basically stopped the majority of my typing, unless when I need to get into the code and start modifying stuff because I can't use AI. That level hits around closer towards when we're refining a piece. Do I do it myself? Yes, I did do everything that I'm working on. Everything you see, the way that I'm kind of flipping stuff, it is all for me. It is all by my design. Put together. I'm using a tool. I didn't build the software that's doing the streaming. I'm using a tool. It's called Wirecast. That allows me to kind of switch between windows and switch between views. So I can, do some interesting things like this and bring it side by side and, have stuff like that and blah, 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 blah. But anyway, I'm trying to do a good job. Anyway, I'm trying to learn, teaching myself. Okay, option 2 is we're going to fix the separator calculation instead of +1. Scan the raw bytes. Yes, but read value doesn't return operators, only the entry JSON. No. Fudge. Option 3 is no good. I don't care about that. Option 2, fix the separator calculation. Instead of +1, scan the raw bytes to count the actual separators. But read value doesn't return separators, only the entry JSON. Let's take a look at this. All right. Okay, Claude. I want to dig in on option 2. Like option 1 is like it. We've been at this for hours now, like nearly 4 hours. I don't want to undo the gains that we've made. I want to get this right. But I think part of the problem is, Claude, is that you're using these magic numbers to calculate how long it is between the next row. That's why there's so much drift, because it's not accurate. Right? We need to actually do a seek and keep counting, keep reading until we find a delimiter. And in JSON, all of this stuff is very easy to determine whether it is a true delimiter or not. And then we know that's the end of the record. Now, can you tell me why that is not possible using file.seek or something similar? rather than continuously depending on the JSON standard library to give us this everything. If we know where to start and the offset, then we can use another mechanism. I need you to explain to me why we can't do this. Because just for context, really hacking. I'm trying to hack together like the most effective, efficient, like slicing the processing down to the absolute minimum here. And this already works. We've already got a fully working operational version of this. We switched branches to begin with at the beginning of the stream because I'm trying to improve it, and I'm using an experimental new decoding library, which means doing all kinds of weird workarounds to make it work with this code, and we're kind of getting into some dangerous territory of super hacking it, hacking it to the point where it's inaccurate and it's not going to be reliable. You're absolutely correct. I've been overcomplicating this. Yes, you have, Claude. Here's why your approach is not only possible, but better. Oh my God. File.seek plus brace counting works perfectly. Of course it works perfectly. How do you think we freaking pass tokens, mate? How do you pass tokens? That's not how you... AI is so stupid and so smart and so stupid. What we can do during indexing: seek to the appropriate start position. Yes. Read the bytes forward, counting the braid's depth. Yes. When the depth returns to 0, we found the exact end of the entry. Yes. Record the exact offset and length. No approximation. No magic numbers. No drift. And there's another chat message. Do I lose my confidence in AI each time it says you're correct? No, I do not lose my confidence in AI. It's not that I have a lack of confidence. It's just, constant reminders to be. Sometimes you have to remember that it's doing all this. It is supremely confident with what it's doing because it believes, based on the context it's given, it's absolutely operating in the most efficient boundaries. But what it reminds me is that I continuously need to give it better prompts, because what this thing here, we're at this point here, I could have said this at the beginning. I could have said, I want you to use file seeking. I want you to use this. Literally, it's going to read the bytes and look for the braces. It's going to count each opening brace and then decrease with each closing brace. And when we reach 0, we are at the end of the entry. And it's just going to seek the file until it reaches that point. That's how you should do it. That's how it should have been done from the beginning. The problem is I made the assumption that the AI knew that. And that's a problem because I wasn't clear. I wasn't detailed enough. And you should do this. When I say be efficient, do it the most performant way possible. Well, that, because, you're running it through an LLM, it's like, running it through a bunch of marbles through, one of those arcade machines where you put pennies at the top and it goes down all the pins and ends up at the bottom somewhere. That's an LLM. Excuse me. It's predicting what comes next. Auto correct, with gasoline powering it. I don't know. So this is a reminder: be explicit. Be explicit about providing the intelligence that it's lacking. It doesn't have this knowledge. It doesn't know. I assumed that it knew. My fault, not the AI. I like getting angry at it. I like getting annoyed with it, but it's not because it's doing anything. It's a computer. It doesn't have a brain. It's not alive. It's not thinking. It's a machine, and a machine operating in unpredictable ways, which is actually part of the fun, to be honest. Because everything I do is written against repeatability, and it has to be something that is always going to be consistent when you run it. Consistency is critical when you're dealing with tooling that does measuring and analysis. You can't have a different result every time, otherwise it's useless. But AI will give you that. So it's nice to be able to work with something that is giving me these challenges so I can get better at it. Right? So here, it's basically got it right now. No approximation, no magic numbers. It's exactly what we should be doing. And it's saying why this is better. Yes, because this is the right design. This is the actual design that we should have used a couple of hours ago I was so focused on bringing in the experimental library that I didn't say this specifically as well. This is what you should be doing. Now I've said it, it's like, of course, we're just going backwards and forwards on this stuff, and that's why it's just, we're not there. So, let's do it. And here's its answer. Here's to answer your question as well, as why I don't lose faith in it. Because it said why I didn't do this before. I was stuck thinking, we must use the JSON decoder to track position. But you're right, we can just read the bytes and match braces. I didn't explicitly say that you shouldn't. I didn't say that you shouldn't worry about just using the JSON decoder. It made that assumption because I wasn't clear enough in my prompt. And here we are. Let's see what happens. Claude, yep, okay, mistakes were made. It doesn't matter. You're not a human, but I am. And I made the mistake in not giving you the clear context on what we could and couldn't do. Yes. Let's do this. Let's use file seeking. Let's read the bytes and match braces. The most effective way to do this to get absolute, complete and total accuracy. No guessing, no magic numbers. Make it so. Absolutely. Let's implement the brace counting approach with exact byte tracking. This will be clean, accurate and fast. It bloody well will, my son. Yes, it will. It will be fast. It will be accurate. It will be correct. And we will have achieved the goal. In fact, if we achieve that, I'm going to dip out of worrying about rendering anymore. We can actually call that as a win today because we've taken an engine, we've added in the most cutting edge possible capable decoding capability possible, and we've refined it to its most performant file seeking we can possibly do. Was planning on doing some visual stuff today, but this has taken longer than I was expecting, but it will prove to be extraordinarily valuable. In fact, it will be more valuable than worrying about look and feel, because that part is more art than science, to be honest. It's less about science and more about artistic creativity and what the right engagement model is and how pretty do we want to make it and how do we want it to feel. Right now it looks like crap. Well, I'll just remind you what it looks like. Let's quit and we'll run that again. This is horrible. We're going to fix this up. We're just going to try and get a percentage loader in here as well when we start this on Monday. And then we're going to fix this all up because this is a huge waste of space. It keeps jumping. It jumps about like when you load it for the first time. This is horrible. But it works. It will work once we've made this full fix in here, and then we're ready for rendering. I think the engine is as refined as it's going to get in terms of its performance. The cleanliness of the code needs to be tuned up again. We can do that. Maybe we'll do that to round things off. We'll go through a full code review of the new motor and run that through Codex. And then call it a day. Call it a day for today. Should take us another hour. 2 hour and a half. And then yeah, that'll be a good place to call it. Rather than trying to bite off any more. I'm waiting for Claude. I'm waiting for Claude to do his thing, to do its thing. It's not man. It's not a person. It's not a person. Claude is not a person. Let's wait. All right. While we're waiting for Claude now I'll be back in a few minutes. Claude is still going. Bringing in file seeking code, trying to make it work. Yeah, it's all theory. It's all theory until you start writing code. Well, you start writing code through an LLM. The byte-to-byte reading is too slow. The offsets are nearly perfect. Let me test if readout works now. Ooh, is this going to slow us down even more? Something's wrong. It only indexed one entry. Great. I might switch the model in a minute to Opus. Give it another go. So can you fix this mess Sonnet's created? If it's working code and it's just unoptimal, maybe you can do it. Oh, we're bringing the buffers back in. Good idea. We had these at the beginning. Yeah, Claude ripped them out for speed. Is there times when you decide to write code for yourself? I mean, until this year, that's all there was. There was only that option. There's only ever been that option. And really, in June this year, there was this crescendo moment where AI became, a silly toy, to being a real tool, which I'm using now. And it was all, write code, look at code, all the time. And part of the problem is I know exactly what I want. I know exactly how I want this to work. But sometimes I just don't want to have to go through the writing or particularly the the prototyping phase, which can be laborious, particularly if you're trying ideas out and you want to change things a lot. That's what we're doing right now. We're prototyping, and I want to try these ideas out. I want to try this parsing, that Armenian recent rings to ever lose your patience and discard AI. No. Okay, let me rephrase that. Discard it, no, but there's many times, yes. Many, many times, and we will get there during this hackathon towards the end, where AI just fails. It runs out of power because it doesn't understand what it is what you're trying to execute on. It can't understand, because you're using language in a way that it might be emotional, or it might be connected to a feeling that it doesn't understand it. It's not human, and it runs out of power. It can't do what you want it to do. You can't generate what you want it to generate. It can't build the experience you're looking for. It's useless, particularly when it comes to visual stuff that's beyond a certain point, because I work a lot with Midjourney. I love Midjourney. If you've seen, you see this stuff, that's all coming from Midjourney. Even the animations is all Midjourney like that. Actually, the animated skull came from Midjourney, and the skull with the horns, and the animations you see, that all came from Grok. Funnily enough, I used Grok for that because Midjourney was rubbish. It could not do what I wanted it to do, no matter how I prompted it. I gave it to Grok and said, do the same thing. It did it exactly the way I wanted it to. I mean, it looks a bit more cartoony than I like, but I'll take it. If it's free. Visual stuff, it's much, much harder. It's much, much, much harder to get what you want when it comes to anything visual, including when it comes with code. But when it comes to mechanics or algorithms or boilerplate code, AI 1.8 slower. Okay. I need to show these results. The braid counting approach gives us exact offsets, yes. But it's actually slower. Way slower. We might be at the limits here. We might be. Let's run it. However, let me test if entries now load correctly with the exact offsets. Might be a failed experiment. Or we need to improve our brace counting algorithm. Does it compile, go, or run it in interpreter mode? This is compiling it. It's not running interpreted mode. You see up here, look. It's compiling it. Yeah, it's going to be accurate because it's doing it's running the logic correctly, but we might be hitting performance limitations on reading on the buffered reader. These are not Let's swap the model. I can't swap the model. We've run out of context, haven't we? Oh man. Oh man. All right. So. Yeah. Using the new V2 design we were playing around with today. Am I familiar with MCPs? Are you? Yes, very familiar. I've used, just curious if you were curious, I've used MCPs for a bunch of different things. Spent some time with the specification as well. I'm not entirely convinced by MCPs, to be honest, at the moment, because you can get the same effect by just asking the LLM to run help on a tool, or you can give it a spec, an OpenAPI spec or a protobus file. Do I document my journey? That's kind of what this is, to be honest. This video, this stream, I'm recording it on YouTube. I'm recording it here like as a file, but I'm also, the live stream is on YouTube. So it's like being recorded all the way through. And I was going to upload these code streams to Twitch if it will let me. I don't know, I haven't tried it. Summaries, no, I don't think I've got any summaries or anything. Unless you're just letting my conscious stream of thought come out of my head. All right, so option A is go back to V1 because, well, that's basically just delete the branch and go back to main, which is fine. At least we've explored it. Option B, no, we can't do this. Yeah, no performance improvement. Option C. What do I want to do? The options are delete. There's a question, is there YouTube links? Yeah, just go to youtube.com/act quobix, QUOBIX. You should see like the live code stream videos, and it's got, there's a few in there now, a couple in there. And would I use brain interface for communicating to AI, similar Neuralink? Yeah, I would if it was available. I mean, I wouldn't have surgery. I'm not that into it, to be honest. I don't want to put any kind of electrodes in my brain. But would I, if there was some kind of ring or I don't know, device I could put in my head or something? Yeah, sure, why not? Absolutely. And if instead of just speaking, I think. Depends on how accurate it is, though. I mean, I'm pretty happy with just talking, to be honest. It works very well for me. So the options we have here is go back to V1 or ship. Do we want to continue banging on this, or do I want to continue banging on this? Don't want to make it even. Do I want to try? Do I want to try and make it even faster? Do I want to ask it to deep dive on? Or do I just say, screw it? Might be over-rotating on this. Might be going too deep on it. Might be obsessing a bit too hard and burning up time. Although we do have some time to burn, which is why I want to do it now. The question is what would be an event in a world that would make you join AI resistance? In other words, completely change your opinion on AI. Oh, you mean like in Terminator and become John Connor or join John Connor? What would change my mind on AI? Well, the beginning of this year, I was like, AI is a waste of freaking time. It's an absolute joke. It's useless. And then that all changed around June. Started using Claude Code. Was about to give up on it, and then that changed my world. And then what would make me stop it? Probably when autonomy has been taken away from me in areas that I find enjoyable in my life, and taken away from me. Then I'd start to say AI is now becoming a menace. Or if AI became a form of control, if AI was put in charge of making decisions about outcomes that affect humans, that would be a bit too far as well. And I don't mean like, advising a human who makes the decision. I mean actually taking decisions that affect humans' lives. I'm saying, no, you get to live and you don't get to live. We're into that whole, what is my ETA for that to happen? Oh, I don't know. I think we're going to have to go through a whole world of pain with AI before we understand where it finds its balance. Right now, we're on the upward slope of the hype cycle, and there's no sign of it crashing yet. There's all these naysayers. Oh, we're peaking, we're coming to the peak. The peak is close. The bubble is coming. The crash is coming. Yeah, we're not. That's not going to happen. Like we don't know what we don't know yet. And I don't feel like it's a bubble. I feel like this is a shift. It's like an industrial shift, a revolutionary shift. And there's a huge amount of investment going into it that we don't fully understand yet. And we don't understand how to realize the value properly yet. But we're getting closer. I like what I'm doing right now. Like I'm building this whole thing using AI. I'm literally having, my code is being created and rendered on GPUs. I would have done it myself, I'd be doing it myself. I wouldn't be using AI. I can code all this myself. But I'm having fun doing it this way. Like I'm enjoying it. And I think that's the difference, is that it's fun. And not that coding isn't fun, but it's the boring, monotonous stuff that puts off most people. It's what most people give up, is because you do have to do a huge amount of monotonous nonsense. I need to make a decision what I want to do here. Do I want to continue banging on this? Do I want to try and refine the algorithm? Or do I just say it's good enough is good enough? Because the mechanism that we've got, let's just one more go. Claude, can you actually, you know what? I'm going, because I've got nothing to lose here. Let's compact, and I'm going to open up Opus. I'm going to change the model. We're going to put in the smart brain and say, smart brain, take a look. And to answer your question, Taras, I have no idea what the ETA is. I have no idea when that's going to happen. Guesses. I know nothing when it comes to predicting the future. All I know is how to adapt to what the present. I've got predictions for the future, and I think AI is. We haven't realized the value of it yet. It's still, people are. Because it's still got to go through the porn phase yet. That's starting up. With every new technology, porn is usually either the pusher behind it, it's like the technology that drives it, or it's the one that takes it mainstream. And I don't think we've been through the AI porn thing yet. I mean, it's probably fully underway in some places, but it hasn't reached its conclusion. Now it's where usually the technology runs out, and then you'll see like business applications start appearing from it because it's been so widely deployed. That's just my thoughts on it. Could be completely wrong, but I don't think we're there yet. We haven't realised how powerful it can be, because it is stupid as hell and brilliantly smart at the same time. I'm just gotta wait for Claude to get his stuff together in a pile here, and then we can change the model and say, do you take a look at this? Can you take a look at this, Claude? And say, Claude, I'm just saying what I'm going to say to the LM. I'll just queue it up and wait. We'll just wait for the compacting to begin, and then get a different model to have a look at it. All right. Model. Opus. Hey Claude, can you take a look through the previous conversation and catch up on just, or make sure that you're up to speed on what we're doing here? We've got 3 options. We've been spent about 4 hours playing around with the experimental JSON decoder API. We've been trying to improve the indexing performance by scanning and reading files and looking for opening and closing brackets. But you know, if we try one way, we've got, you know, super fast reading of a 5 gig file, you know, 6 seconds, which is amazing, but it doesn't work. It doesn't work accurately because all using magic numbers, and you're guessing where a payload ends, and the drift is massive, and anyway, it just doesn't work. The code you built for that, I don't even get to see the code. I know it doesn't work. I can visualize it in my head. Then we have the other option of continuing down this path of beating the code that we've built right now and trying to get it to run faster. The byte reading is actually slower than our V1. And I can just delete this branch, and we can go back to main and continue on where we were. And all is good in the world. But I don't want to give up just yet. I want one more pair of eyes to look at this and decide, you know, if we have built this incorrectly, if the algorithm we've implemented is performant, or if it's, you know, we're overlooking something completely obvious. So I want you to take a look at this with completely fresh eyes. Now what I'm going to do is I'll put that in there, and I'll say ultra think, which will put on whatever ultra thinking is going to do, and look in super depth, and I'll put some clarifying elements in the prompt to make sure that it knows what the boundaries are or not. I want you to implement, or implement is the wrong word. I want you to think about the most performant algorithm we can possibly use with the standard library that would allow us to improve upon those 13 seconds. Actually, no. Let's allow us to keep our 6-second time or better whilst being accurate. The current approach we have with byte reading and parentheses matching, it's bracket matching, and bracket matching is slow. It's slower than V1. So I want to make sure that we've looked at and have thought about doing this in the most performant way possible with absolute minimal memory use, or should we just delete all this and go back to V1? All right, let's see what happens here, and this is our last ditch before I give up. To be honest, it's been nearly 5 hours. If this doesn't work, then I'm going to say it's a failed experiment. We have made progress in the sense that we know we can't refine this engine anymore. The engine is as good as it's going to get, and we're going to have to deal with what we get. For now, with the current build, with the current design, we'd have to rethink the design if we wanted to improve performance if possible. But I don't have a solution for that right now, so this is what it is. But we're gonna give Opus the opportunity to prove its worth. Show us Opus. Prove that there's hope. Give us some hope. Otherwise, we have just lost 4 hours. Well, we haven't lost 4 hours. We haven't lost 4 hours. We have gained the knowledge that we cannot move down this path. We will gain nothing from it. This all stems from a thought that I had on the couch last night when I was thinking about what we built over the day yesterday. I was like, we can do better. We can do better. Well, maybe we can't, because we've got to give up something else in exchange for that. And it's either you want to go fast and be accurate, you can't do both. And you know the solution is like, well, build it in Rust, go faster. Yeah, that's not the solution, is it? Ugh. All right. So, what does Claude say? Claude says, looking at this with fresh eyes, I can see the fundamental challenge that we're facing. It is a fundamental challenge. Let me analyze the situation. Fresh analysis with the performance problem. After reviewing the entire journey, here is the core issue. This is what we face today. This has been our journey today. JSON v2's need, the new experimental API, the speed comes from read value. It reads raw bytes without parsing, but we need the exact byte positions. We need that for random access later. That's the whole point of the index. And JSON, v2, it doesn't provide input offset. And we discovered this earlier. It's a massive limitation for us. Massive. So the current performance comparison, we got V1 baseline, it works fine. It's 372 megabytes a second in terms of parsing. We got it up to 746, but our logic was rubbish. It didn't work because it drifted. And when we tried to fix the drift properly, like you actually how you would do it, we're 100% accurate, but it's super slow. Now, why is the braid counting? This is accurate. This is like 100% accurate in the performance. Like I'm happy to see this because this is exactly what the problem is. But why the braid counting is slow? Looking at index build, the V2 version that we done, this is 5 billion times. each byte. Even with buffering, that's 5 billion function calls versus V1's optimized internal parsing. Yes. So, the overlooked optimization, and this is what I wanted to see. There's another question from Taras. Companies are starting to modify their T's and C's to add worldwide, non-exclusive, irrevocable, royalty-free, fully paid right and license for your de-identified data. Oh, I see. About collecting. Oh, yeah. I don't know. I don't know where this is all going. This is new. This is a new tool that we have in our inventory that is going to shift so many things in so many ways that we aren't even really comprehending what that means. And from that point of view, I mean that jobs, careers, value, like the whole concept of what we're doing right now. Oh, they don't even consider this data yours. Oh, that's your data. Oh, I see. I don't know where this goes. Everything that I do, like, it has to be by the book, like data protection laws, like there's no circumventing anything. All the software we build, for example, has to be go through a whole bunch of validation, like SOC 2 and all kinds. I'm not going to go into it. It's endless, but so the questions are, or the points are, they avoid any data protection laws, and who monitors the quality of de-identification. Yeah, this problem is going to get out of control, particularly in, I would say, well, just about everywhere. I think anywhere is safe. I don't think any country is safe. Everywhere is at risk right now. We're entering that 100-year cycle where we go through growth, lots of growth, and then we get into the gluttony, weakness, and that creates challenging times, and then we get into conflict, and then we start again. This 100-year cycle of humanity. And if you think back 100 years ago, where were we? What were we doing? What happened? What happened during the teens? The AI doctor scribes, they comply with HIPAA in the same way they store your data. Yeah, I don't know. HIPAA's another one of them. Another one of those. It would be PCI or HIPAA. coming back to this is overlooked optimization in Claude. We can read the complete JSON chunked. Read a chunk. Yeah, chunk it. Yeah. Stick with V1. Yeah. All right, chunk it. Fine. Okay. Yeah. So it's basically saying this is our last chance. The last chance is we can't improve the performance of read because that is reading a byte by byte. Right? But we're going to do a chunk instead. We'll chunk it up. Okay, that makes more sense. I should look at the code. I thought it was chunking up. That's my mistake. I assumed it was doing chunking. Jesus, I've got to get better at this. You having sorry, they're looking at the chat again. It says Taras says, well, you convinced them to delete 2 months worth of data from a specific location. I don't know how you convinced them to do that. That must take it a while. That must have taken a lot of work and effort. All right, let's do it, Claude. All right, Claude, do it. Let's try it. Let's try chunking. Let's see if it improves it. Because we are accurate, but we're slow. If we can speed this up and get to 7 seconds, man, I'll take it, and that will be it. We'll call it a day. I've just been sent a really interesting link. While we're waiting for Claude to do his thing, I'm gonna swap over to Chrome. Look at this CodeWiki. I just got sent this by one of my colleagues. Well, it was sent a while ago. Thank you for that. I won't say your name. I don't have your permission, but I will. I won't take a look at this. This is something that's very interesting to me. Look at this. Go. Automatic docks. I hate these stupid Apple-esque animations. They're so annoying. But this feature is really interesting. Lib open API. Let's do that. Useless. Useless. Oh, hello. We've only got 3 repos in here. Oh, okay. Well, you're not very useful, are you? Thanks for reaching out. We'll review a request. Then what's the freaking point? This is not AI. This is like, yeah, we've scanned your repo, we ran something against it, and here's the result. Ta-da! AI. All right, great, thanks. Yeah, love it. Very useful. All right, well, let's see what the pre-canned ones. Oh, hang on a minute. Hang on. Yes, go. Now, what have we got in here? Kubernetes, React. Okay. So take all that. All right, never mind. I'm just going to shut up. Try it with your own repository. Okay, well, that would be good if it actually... That's quite nice. That's a quite nice animation there. Look at that. What is that? This all looks like... yeah, this is Angular. But what is that? I like that. What is that? Oh, it's a canvas. Scroll animation container. Where'd the cube go? There was a cube there a minute ago. Where'd it go? It was like in front of the This is shit, who cares about that? There was a cube in front of it that was doing some kind of glassy like refractions. Looked really nice. It's gone now. What? Where'd you go? It was this, but it was in here. Well, I don't know what happened. It was there a minute ago. You saw that, right? I don't know. What was Claude want? What do you want, mate? Yes, test random. Wait, only one entry? That's wrong. But the time improved. Oh, this isn't going to work, is it? This isn't going to work. This isn't going to work. I think we're reaching maximum capacity here. Maximum capacity of give a crap. And we're going to have to... Uh-oh, it's only finding one entry instead of 70,000. The chunk reading is returning after the first object. Let me fix this. We do not return immediately when we find a complete object if we're still processing. Actually, wait. Let me check how the chunk reader is being called. The issue might be that how we're continuing after each object. I see the issue. In their chunked implementation, after finding the first object, the next call is likely hitting end of file prematurely. The problem is in the error handling. Non-EOF error. That's not what we're looking at. Now let's test the fix. Congratulations, we have shaved off 3 seconds from 24 seconds. You are now at 21 seconds. Rubbish. Rubbish. Let's go, Claude. Let's go, buddy. Let's go, buddy. Come on. Let's do it, mate. You can do it. You can do it. You can make this chunking work. The chunking will work. It will give us back those seconds that we've lost. It'll take us from 13 down to 7. That's what it's going to do. It's not going to take us from 24 down to 17. If it does, chuck it in the bin. I don't know what you're doing. It's taking too long. This is taking too long. Yes, mate. Let me kill it and check what's happening. Oh no, I've broken it. This is the smart model, remember? This is the smart model. I see the problem. There's 2 cooling buffer write byte for every single byte. That's 5 billion calls to write byte. Yeah. Stupid. How you generated it? Why? I don't know. Smart and stupid. Smart and stupid. We started an object, we haven't finished it. Great, now we're writing chunks instead of individual bytes. This should be much faster. It should be, but I don't believe you, Claude, right now. I think we're running at the absolute edge of optimism on this. I think we've squeezed as much as we can out of this lemon. It's just not gonna get any more juice. Yeah. Much better. 8.1 seconds. But it's still only finding one entry. Well, that's no bloody good, is it? It doesn't mean anything. If you get 8.1 seconds off, I'll eat my shoes. I'll eat my shoes. I will. Seven point 7.82 seconds. Total entries found 1. But that's not right, is it? There's 70,000 in there. 70,000, you see. 70,000. Come on, Claude. Come on. The chunking has got to work. It has got to work, my friend. It's the last chance. We've read bytes. We have tried serializing and decoding entire structs. We have tried guessing. We've tried it all. We've tried all of it. All the tricks. And then now we're doing it all wrong. I don't know what's going on. I can't find the next entry. The logic is flawed. The logic is flawed. It is flawed. Flawed. Thought for 75. We have been running 11 minutes, Claude. Oh no. We're bringing in debug statements. This is the next frontier. Is integration with agentic programming and true debugging. So we can do profiling. Profiling is already solved. But debugging is not. It is not solved. And yes, you can use it with MCP, but it requires all this complex wiring and hacking and fudging and mucking about, and it's still as fragile as hell. A friend of mine called, you know what, I'm not going to say his name because I don't have permission, and it's not released yet, but I know somebody who's building a tool that might solve this. As soon as it's ready, I'll talk about it, but I don't think it's ready. It's doing a soft launch and it's not ready yet. I don't think they are. I'll let you know when they decide it's ready to go. And I'll get permission from them. And then I can show off what they've been working on. Great. Very exciting. I'd use it. If I can fit it into my workflow, I'll absolutely use it. That's the key. Every developer has a different workflow. Every engineer does things slightly differently. You know, they've got their own favorite tools and their favorite way of configuring things, and you know, it's big business is that. Well, not business, isn't. There's no money in it, but it's important, you know, for developers, engineers. Your environment is where you work, and how you set it up is important. And I think there's been a bit of a resurgence on it recently. People like DHH have been working on, was it Arch and something like that. I don't know, like Omarch, I think, is what he's been building. Like a ready to go, personalized, out of the box, set up to look like a cyberpunk screensaver. Truly like custom everything. I need things to work, quite frankly. I need my apps to run when I click them. I need my monitors to work when I turn them on. I need my sound card to work. I need my video production to work. I need the camera to work. I need the hard drive to work. And I just need it all working. And with Mac, that happens 99% of the time. With Linux, that happens 0.9% of the time. I spend more time tinkering with that damn thing, trying to get it to work, and then trying to tune it than you do actually using it. And that, I think that's part of the attraction. It's like a project car. It's never done. It's never fixed. It's never working. It's never right. It's never there. It's never what you want. It's always like, oh, I've got to buy another bit, add another bit, fix this bit, take it apart again, put it back together. It spends more time being worked on than driven. And I need to drive. I don't need to work on the car. I want the car to move. And that's what this is. My Mac works for me just fine. All right. Time to make a decision. This is it. This is the pinnacle of the day. After extensive optimization attempts, we have been around the houses for hours, and gone every second around of it. The current status of the chunked approach is that we're only finding one entry out of 70,000. The cause is the multi-reader transition between the prefix and the main file seems to be causing a premature end. What? What we've tried. Fast but buggy. All right. It's saying give up. Give up is what it's telling us to do. Give up. You said you'd be happy at 7 seconds. We're 8.1 but broken. V1 is a solid 13 seconds. Yeah, I know. I don't need you to keep convincing me to go back there, Claude. We're not going to be able to use the JSON v2 library. It's just average because of our input offset. It doesn't exist, which is good and bad. It's faster, but no use to us. Is it worth more hours of debugging? Tried all the main strategies. We're fighting against the library. We're fighting against language, and we're fighting against the design of the standard library and even the experimental replacement for the standard library. We're fighting it to get more and more and more out of it, and it's not every time we turn a different way, we try a different approach, we're finding another limitation that means we can't. I want to know what this. I want to figure out more about this. Let's just do this one last. I'm curious now. We're 1% away from just deleting the whole thing and saying, well, that was it. We have made enough progress to know that this is a dead end. I need to scratch this itch just one last bit. Root cause: the multi-reader transition between the prefix and the main file seems to be causing premature EOF. Can you investigate what this is? I want to understand. You say this is the root cause analysis, and you say it seems to be causing a premature end of file. Let's learn. Let's get to the absolute bottom of this and figure out if we're doing something wrong, or if we've made a configuration change and we're just one tick away from having the success we need, versus we are truly beating a dead horse to death here. And I need to shut up and stop. You're absolutely right. Aha. I see the setup. We're reading the first. What do you mean you see that? You wrote it, you nutcase. Where entries start, then creating a multi-reader that combines the remaining bytes of the first 4 KB chunk and the rest of the file via a hash reader. Okay. Let me add detailed debugging to see exactly what's happening at the transition point. Interesting. The multi-reader itself works perfectly, and it successfully read 133 KB without end of file. So the multi-reader transition is not the problem. Oh yeah, I didn't think it was. Let me check what's different in our actual implementation. I think the issue might be with the buff.io reader wrapping. Perfect, both the multi-reader and of course they work fine. I think I found it. When we found the closing bracket of an object, we immediately return, but we've already read a whole 64 KB chunk. What happens to the rest of that chunk after closing brace? We're throwing it away. Never trust an LLM. It's like never trust a fart. You can't trust it. You can't trust it's going to do the right thing because it's not. It's not going to do the right thing. It's going to do the wrong thing. Well, it's going to do a thing. Not maybe wrong or right, just what would, like, statistically this seems accurate. Whoa, what was that? Bingo! Bingo, it says. Bingo! There are 7,437 bytes left in the chunk. After we found the near the first object. Yes, those bytes contain the start of the next entry. Buffer readers consumed 64 KB chunk, but we only used 58 KB of it. The remaining 7 KB is sitting in the buffer's internal buffer, but our next call doesn't know how to handle the situation properly. Alright, so buffer is all messed up. Buffering logic is rubbish. Let's close this out. Let's get to the end of this. Fix the buffering logic. Fix the chunking logic. Because it's not the standard API and it's wrong. It's our rubbishy code, Claude. It's our rubbishy code. We have gone down to the depths. And I think we've explored the bottom of the ocean on this one. I'm glad we have. I don't think there's anything else that I can think of that we can explore around this to make the most efficient performant code possible. Perfect. Okay. Yeah. So you're realizing that you've got the logic wrong and you found the bug and you've got a partial chunk that's unrecovered. Your math is all wrong. And then the logic is throwing it away. Yeah, as I said, the logic is wrong. And then we're skipping the comma and we're messing it up. After finding the first object. Oh, wait. Let me check the logic again. Oh, hang on a minute. You've made it. Oh, here's the real bug now. Oh, you had to think about it again. We're not properly handling the transition between the buffered data and the new read from the file. Yes, the buffer reader returns the buffered KB and fills the rest with new data, giving us a full 64 KB chunk. Wait, that can't be right either. Oh, I think I finally found it. La 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 la. Let me implement a fix. Alright. Pre-buffering. Why are we pre-buffering? Smaller chunks. Oh, this all feels like a big mess. Feels like a big pile of mess. Big one. Same issue with 8 KB chunks. The leftover 7,000 gains the next end. Yes, it's returning it. You've got a math problem, mate. It's a math problem. It's a math problem. It's a logic problem. Aha! Buff.io reader only returns the buffered 2 bytes. It doesn't try to fill the rest with the request. This explains everything. In our case, we are getting it wrong, and then getting it wrong, and then doing it again wrong again, and then we're wrong again, and then we're wrong, and wrong. But now, aha! I finally see it. This confirms the issue. Buff.io is returning partial data from its buffer, not trying to fill our request. But wait, there's more. I've mistaken it again. Oh, I finally see it. Okay, the problem is not with Buff.io reader or multi-reader. The problem is that we're losing data between chunks. The math is wrong. The math is wrong. But what if the chunk ends in the middle of a string or in the middle of parsing? We need to maintain the parse state across chunk boundaries. The actual bug. Yeah, logic. You've lost track and you're reading the wrong amounts. It's so straightforward, but the logic we've created for this, it seems to be mad. It's still going around. Yes, I did accept your LinkedIn invite, Taras. I did. Nice to meet you. Smaller buffers. That's not going to help. Changing the buffer size is not going to help. We are just going round and round and round now. We are going round and round and round and round and round and round. Now, occasionally this does end up. It does actually fix it and get itself out of a hole. Most of the time it says, well, I've made some progress, but I can't really do any more. And then we're totally screwed. And I think we're at that point. I think we're there. I think we're there. I'm just gonna let it go. Just let it mess up for a bit more, and then we're done. You let me down today, Claude. Well, you haven't let me down. You haven't let me down. Let me say that. You just can't. You can't squeeze any more lemon out for me. I probably could if I did it myself. With 4 KB buffers, it's finding many more entries. Maybe it is a buffer size. That doesn't make any sense. I still don't know what it's doing now. Oh, look, it's run out of context. Look at that. It's going to error out in a minute. It's going to error out in 1 moment. It's removing lots of debug code. That's promising. Now let's test the clean version with the 4 KB buffers. Still waiting. Still waiting, Claude. Still only 1 entry. Oh, God. I don't know what it's doing now. Just let it run. At least we know on Monday. Straight to visual. We're going straight into design. We're going to review that code. No, we don't review the code. The code is just trash in there anyway. We'll just start designing. Then we'll clean it up. I don't know what it's doing. It is coded itself into chaos. It is lost in Narnia somewhere. Lost. I don't know what it is doing. What's you doing, Claude? It's stuck looping and looping and looping on chunking logic. Getting confused more and more and more and writing more and more and more rubbish. Yeah, can't make the buffer work either. So we're hitting an end of file on the second call. Issues clear. When we read a 4 KB chunk of the object, it ends at byte 754. We lose the remaining 3,441 bytes because of the buffered reader. Those bytes contain the start of the next entry, but we never put them back into the reader. We need to either keep reading. Close. 8 seconds. Keep telling me to go back. Put unused bytes back somehow. I can't do that. Let's just see this. I'll ask this one question, then we'll call it a day. Tell me more about this. Actually, before we do that, I'm going to have to change the model because we're out of context and I don't want to clear. Actually, let's do a compact. Let's do that. Let's just compact and ask. I don't want to change the model. It takes a minute. While that's doing that, I'll be right back. All right, last chance. Talk me through this. What do you mean by this? What do you mean by this, Claude? Let's finish strong. Come on, let's finish strong. Current problem with read. Okay. When we call buff read a read chunk in our read complete JSON object function, the buff.io reader pulls in 4 KB from the underlying reader into its internal buffer. It copies those bytes to our chunk and it advances the read position by 4 KB. Okay. So when we find the first JSON object, byte whatever, we can shoot 4 KB from the buffer. We only needed 754 bytes. Yeah. The remaining 3000 containing the start of the oh. Well, of course. That's a major problem. It's the the buffered reader is essentially discarding anything that's unread, but we need those bytes. That's the problem. That's why we're struggling with this in the particular implementation, is because, well, it's because of how the standard library is operating. It's discarding the unread bytes, so we lose that. That means that we can't parse effectively because they're gone, and that contains the start of the next object or the next delimited position. So peak is going to give us that without destroying the bytes, reading it in effectively, moving the head, the seek point along. A peak is like a look, but without damaging. It's like a read-only operation. That doesn't make any sense when you've got read. It's a non-destructive read. It reads the bytes without consuming them, i.e. removing them. Yeah. That might be the key here. Well, it might be. Well, it might be a key. The key benefits, no overhead, no data loss. Yes. Yeah, let's try peak. Let's do this. And it's our last chance. It might be our only chance to make an impact today. I'm feeling a bit confident here. I don't know why. I feel confident now. The problem with that makes perfect sense, and quite frankly, I would get stuck in these type of situations where I'm now having to find out this myself. You know, deep, like realizing that there's 4 KB. Excuse me. As I'm trying to. Excuse me, 1 second. As I'm trying to figure out my way through what's going on, and I'm using a debugger, I would have to figure out that those bytes are being consumed. So this is kind of as you're building the chunking mechanism, you go through this learning exercise, and we did it with the LLM. I mean, you could easily just read the docs and absorb all of it, but this is effective. This is like whack-a-mole. You know, whack, and so you're in the corner, you go, what do we do now? Let's test. Yes. Let's test, because this is it. I'm cooked. Come on, mate. Come on. Finish strong. Let's finish strong. Keep it. This is it. We can walk away as heroes here, Claude. Are we going to walk away as heroes? Or are we going to walk away as a frustrating end to a momentous week? Which is never great, is it? I'd like to be able to say, yeah, we shaved off 5 seconds today. That's huge. For me, huge. Now we're using peak instead of read. We're not going to consume the bytes, which again, you just don't not think ahead to be that explicit. I wouldn't think, to be honest, at this point. I would be going through this myself. I would be doing this debugging. Like, I'd be adding those bloody counts and debug statements in there myself. That's exactly where I would be. Now just gotta wait for Claude to figure out what it's doing here and get this build going and rocking and rolling. Verify performance meets the 7-second target. That is it's bold, man. I don't think we're gonna get there. 7 seconds would be nice. Now let's test the fixed version. Here we go. Heroes or frustration. Now we're finding multiple entries now. We've got 35, but there's still an issue with the parsing. The error suggests we might be including extra characters. Now we might actually have a chance of fixing it because we've got the correct math. Or maybe not. There's definitely progress though. Look, there comes in a huge, much bigger chunk of the JSON. You got it, Claude. Come on, mate. Come on. Come on. Let's pull it out at the last minute here. I'm going to pull it out at the last minute. Back of the net. It's going to be a kick to the back of the net. We're going to do a little bit of debugging here. We're going to get to, we've got 35 entries. Now we've got 48 entries. Now we've got 100 entries. Now there's 200 entries. Just figuring out the edge cases around base 64 encoding or large objects, it seems. Oh, come on, mate. Come on. Come on. It's been a mission. It's been a mission, my friend. The problem is becoming clearer. We're including the comma separator in our object types. Half files have entries like object, comma, object. We need to capture just the object part without the comma. Let me fix this more carefully. Yes, that is correct. You've got your delimiting logic need to be tuned up there. But I've always got to make sure that we count those damn brackets, otherwise back to square one. Excellent. The byte by byte approach works perfectly and reads all the 100 entries sent. Yeah. Come on, no. Don't be doing that. Make sure you don't give up on the peaking. If you go back to byte by byte, even if it's an experiment, we're going to be right back to where we are again with 5 million reads. Billion reads. All right, you fixed the delimiter, separators. We're using the peaking instead of the reading on the chunking. So we're not consuming the bytes. Back to the beginning. I think we're going to have to do some serious. If it works, tomorrow is like, well, it's going to be mostly like the first. Well, not tomorrow. It's Saturday tomorrow. I am not streaming tomorrow, and I'm not coding either. I'll be doing other than life things, normal things, not software. Sunday, flying out to California. Monday, back in the office in the hackathon, but streaming straight off of my laptop. I am on my laptop right now, but I've got my whole setup here going. Still getting stuck on brackets. Still not working. Is it the half file we've been generating? Is this been a ghost we've been chasing because we've got messed up half files? Have we been chasing a ghost for hours because we're assuming the half files are correct? Maybe they are, maybe they're not. Haven't looked. Still fine. So those half files are pretty crazy because they're generating base64 encoded bodies, and this is still going round and round. It's still going round and round. Wow. Really is you read byte. We're right back to this. We're right back to square one. It's the LLM has done a full loop. It's done a full loop, and we're right back to this. Let me test this simpler version. Yeah. Read byte is the problem. We can't read a billion bytes. Billions of bytes. Look at that, 24. Right back to 24 seconds again. Undid the work. Put it right back in. And straight away, couldn't make the peak work. Couldn't make fantastic, but let me create an optimized version that uses peak and read more efficiently while maintaining correctness. In other words, hooray! I got us back to the beginning. Right back to the beginning. All right. You know what? We're just we're going to do this. We're going to do this. We are going to give up. We can't make this work. I can't make it work. Not any faster. It works. It works fine. It's efficient and it's fast. But we can't make it any faster. So we can't do it. We can't do it. It's time to give up. It's time to walk away. With all this mess. Total mess. All of it. Lots of experimental stuff. So what we're going to do is going to say this is a failed day 3 mess. No, it's not mess. Today we tried to optimize the engine. We looked at replacing with experimental JSON library. We looked at using chunked parsing. We looked at using different readers, the buffered reader, buffered IO. We looked at peaking. We looked at CKit. Well, we did all of it. We went through every combination, and we couldn't maintain speed and accuracy. If we got faster, we lost accuracy. It is at the limit. I think we're gonna have to just accept that for 5 gig plus, we're looking at a 13-second load time on a reasonably fast computer. I'm going to commit that. I'll commit that because we'll keep a record of it. We won't put the binaries in there. Get rid of the binaries. But we'll keep all the mess. No. We'll just get rid of all the binaries we don't need. Commit. And then we're just going to delete all of these. All these test binaries move to the trash. Back to V1. Let's recompile V1. Actually, we don't have any of that, do we? There is no go. There's just the tag doesn't need to exist because it's in there. Then we're gonna do. We've done what you know. The 5 gigabytes should take 30 seconds. We know that. But what does 500 megabyte take? 1, 2. Alright, well. 1.3 seconds for half a gig. I can live with it. I can live with it. I have to live with it. I have to live with it. This is it. This is as fast as it gets for me right now. So if you can wait, if you can wait a second, 1 second, you can get half a gig of data. If you wait 3 seconds, you can get a gig of data. So 3 seconds load a gig. I think that's okay. We've tried, we've pushed it, we tried every combination that I can think of, that I know of, that is going to get reads in the most effective manner, using metadata, seeking, chunking, asynchronous, using the latest experimental decoders. We can't get any faster. We cannot go faster and maintain accuracy. We are sacrificing one for the other, and without accuracy, this is all pointless. So, back to where we were this morning, but at least we know now we're as optimal as we can be. We've closed that window. That window is closed. And I'm just going to bring up my. Let's do this. Let's on a quit, and we'll rerun this with 50 meg file.har. Let's see how long it takes. 50M. It loads 50 megabytes in 144 milliseconds. Can deal with it. It loads 500 megabytes in 1.3 seconds. I can live with it. I'm gonna have to live with it. We can load 5 gigabytes. It should be 13-ish seconds. Seconds. All right, well, is it? I can't make it any faster. I tried, everyone. I want to make it go faster, but I can't. And you know what? Let's just do this. Claude, I give up. I've reverted all the changes. They're all gone. We're going to stick with V1. It is our only option. We can't make it go faster. We have tried, and it is optimal. We are loading 50 megabytes in like 100 milliseconds, 132 milliseconds. It'll do just fine. What I would like to try though is a couple more variations. Can you build me a 1 gig file, a 2 gig file, and a 700 meg file, please? There you go. All right, let's just take a couple more variations in here so I can just just so I got some more benchmarks. And I gotta be proud of what we got, because it's as good as it gets. Made the right call. V1 is solid. 13.8 seconds for a 5 gig file is excellent performance. It is excellent performance. It is. I just want more. I know more is possible. I know it is. are you doing, Claude? All right, generating some files. Okay, so spitting out 1 gig, 700, 2 gig. Let's see what we get in performance with those files. And then we can say those are our benchmarks. No, stupid. Please modify Hargen to generate files of our own deciding. That's our generator. Don't generate another 500 meg file and another 50 meg file and just because I set those values, it doesn't mean that they're the way it's supposed to be. Please modify Hargen. Stop being stupid. I'm out of patience. Hard gen. Ah, damn. Damn. There you go. Much better. Now let me rebuild Hargen with the custom site support and generate the files you actually want. Please. Please, Claude. Is it how I code all the time? No, it's not. No. No, I normally get in there and start digging around way earlier in the process. Way early in the process. But I am just letting for the time, because I wanted to do a bunch of experimentation today, and normally that takes days. So what I'm trying to do is compress a bunch of exploration and prototyping really into day one. And we've got a working engine yesterday. I reviewed all that code. I didn't need to change any of it. It was all pretty good. It's pretty simple, and it worked relatively well. The design is fine. But what I'm trying to do today is a bunch of experiments, and I just want to type all the code out because it takes forever. Plus, doing it live, I'm not a great live coder, to be honest. I can do it, but I'm a bit sloppy, a bit messy. I just prefer to do it like this, to be honest. And normally when I code, because right now I've got everything like zoomed in on the resolution, and I've got a much more elaborate setup. I've got much more real estate on my desk to be able to do this type of stuff. But I do want to be able to capture it when I'm streaming, sharing my process. But it looks different when I actually do it for real. It looks different on my desktop. This is kind of set up for broadcasting so everyone can see it clearly. But normally I don't have like an entire terminal up all the time, which is my main thing. It's usually IDE and terminal and another terminal, and I've got all my chat all over the place. Alright, have you generated my files yet? Yes, you have done a 1 and a 2 and a 700. Alright, great. While you're testing it, I'm gonna test it too. Let's test it. Let's do the 1 gigabyte. How long does it take to index and load a gigabyte? 2.7 seconds. 2.75 seconds. Okay. It's okay. Let's try the 2 gig. 2.7 should take 5 seconds or 6 seconds. .4 down the middle. I can't really complain about that, can I? You complain about that. It's 700. 1.8. All right, I'm just being too anal about this. If we go back to chord 1, and this is basically what we were seeing. 700 is 1.9, 1 gig is 2.7 seconds, 2.2 is about 5.5 seconds, so 2 gig is 5.5 seconds, 5 gig is 13 seconds to index. We can take in 700 meg, and we can take in a gig and get it in front of you in 2.7 seconds. And it takes 196 nanoseconds to pass each half file entry. And the throughput is consistent. It's linear, scales linear, which is perfect. It's 195. Oh, it's microseconds. Jesus, I thought that was nano and micro. Wow, that's pretty fast. No degradation. The 5 gig file actually performs slightly better. It runs even faster. 10 gig file will take 20 seconds. All right, I'm happy with it. I think that's good enough. It's good enough. We've confirmed that we can't go any faster. This is our theoretical speed limit. It's the speed limit right there. I'm gonna add this to the README and say that's it. And commit it, and we're done. So bring up the code. I'm gonna add it to the README. There's our table. And we're gonna call it horrific. Changing the name. Horrific. These are our, we're going to call this is our foundational numbers, and this is where we start. I've spent a whole bunch of time on this today. This is a tool for measuring statistic runtime duration. No. This is a tool for passing in very large HTTP archive files. Those HTTP archive files are generated by our customers who are having problems with our products. And the first thing an engineer needs to do is load up that HAR file. Oh, I'm talking about Hyperfine. Oh, sorry. I didn't see that line up there. I apologize. I'm trying to write this here. By the way, you can try Hyperfine. Oh, I don't know what that is. I've not tried it before. Oh. Chunking and scanning and streaming. We tried everything, and this is as fast as we can go accurately. Hyperfine. Talking about Hyperfine, I don't know what it is. Let's have a look. Hyperfine. What is? Oop, not Hyperfine. Hyperfine. That's not it. This must be it. Shock DP. That looks popular. Cool. Oh, it's just a benchmark. Okay. Yeah, we'll give this a run. Not today. I'm done for the day now, but we will give it a run tomorrow. Not tomorrow. Monday. Looks popular. Looks cool. Looks useful. Thanks for the tip. Appreciate it. Hyperfine. Yeah, I'll leave that up there. We can come and have a look next week. All right. Horrific. We renamed braid. Horrific is more fun. Yeah, it's more fun because it's more focused. It does one thing very well so far. I'd like it to be faster, but this is as fast as we can make it. It's accurate and it's fast, and we're looking at 2.7 seconds to load in a gig. Yeah, with minimal memory use. I'm okay with it. We'll be all right. We'll be fine. We'll be fine. That is good. All right. Let me commit that. I'm just going to go and commit that in Tower. There's a bunch of, what is in here? Binaries, test performers, don't need that. Hargen. Let's do this updated. Hargen to be more configurable. I can't see this. I absolutely can't see what I'm typing here. Too small. I need to fix that later. Not your problem. That is my problem. And then we updated the README as well. What is it? We're showing the speed limit. We tried everything today. This is as fast as we can run right now. All right. I'll leave the red. We don't need to worry about the rest. Well, thank you for watching today. Appreciate it, Taras. Thanks for the tip on Hyperfine. I'll take a look at it. Anyone else who's watching, I'm not sure if you are on YouTube or on Twitch, thank you for sticking around. Thank you very much for paying attention. It was successful in the sense that we know the speed limit. We know we over-rotate now. We've done that. Can't go any faster. We cannot go any faster. Tried everything today. Everything. I was itching to do it last night, but I held back, and I'm glad we did because we did it together. And we've all seen the journey. If you are watching this and you have any tips, please let me know. But I can't think of any way to make this any faster using those mechanisms and techniques we've already gone through. So thanks so much. I appreciate your time, and I will see you on Monday. I'll be streaming a little later. It won't be 8:30 a.m. Eastern. It'll be more likely 8 a.m. Pacific, which will be 11 a.m. Eastern, because I'll be on the West Coast. And if you're around next week, I will catch you then. Until then, keep on hacking.